A very good evening to our respected delegates, distinguished guests, all participants, and members of Indian Society of Remote Sensing. I am Dipannita Mukherjee, member of ISRS and faculty member of CAT Center, Jadavpur University, Kolkata. I thank all of you for joining us for today's webinar. Today, we are here to commemorate the occasion of GIS Day 2020. I hope it will be a fruitful evening in terms of knowledge sharing. I request all of you to keep your microphones muted and cameras off. This will actually help us to run the webinar smoothly by reducing the internet traffic. Now, at first, I would like to invite Mr. Subroto Haldar, Honorable Chairperson ISRS Kolkata Chapter, for delivering the welcome address. He is an eminent executive engineer in Water Resources Investigation and Development Department, Government of West Bengal, India. In spite of being a civil engineer, he did specialization in geotechnical engineering and hydrology. He served as Secretary of Indian Society of Remote Sensing, Kolkata Chapter, for the past 4 years. Sir, please.
A very good evening to everybody. Today we are assembled here to celebrate GIS Day 2020 by Indian Society of Remote Sensing Kolkata Chapter in association with CAT Center Jadavpur University. The first formal GIS Day took place in 1999. Environmental System Research Institute ESRI President and co-founder Jack Dangermond credits Ralph Nadir with being the person who inspired the creation of GIS Day. Nadir considered GIS Day a good initiative for people to learn about geography and the uses of GIS and wanted GIS Day to be a grassroots effort that was openable to everyone. A GIS Day message from Jack Dangermond ESRI. For all of us involved in GIS, this day is a chance to showcase what we do as GIS professionals. For all of us, it's a day to tell our stories to others. It's an opportunity to demonstrate the values of your work and the meaning of maps and their power. This is an opportunity to go into schools, to have open houses, to teach kids, our next generation, what GIS and mapping technology is all about. It's an opportunity to tell others what geography, the science of our world, is all about, and to demonstrate the application of geography in very meaningful ways. GSD is not just an event, it's a global movement. This day brings universities, government agencies, schools, non-profits, and GIS professionals together to build knowledge of GIS in their communities and create understanding about the world we live in. GIS Day happens because we have a passion for geospatial thinking. Through our event, a seed is planted that grows GIS understanding in our community and around the world. Each of us has the power to inspire and change the world through GIS. Welcome everybody to join the movement on GIS Day 2020. GIS Day provides an international forum for users of geographic information systems technology to demonstrate the real world applications that are making a difference in our society. GIS Day is a fun day to showcase how GIS is used, discover and explore the benefits of GIS and inspire our community by celebrating GIS. GIS is about maps. We know a map has the potential to change the world, inspire action and serve well-informed decisions. It all starts by creating beautiful, powerful maps that reach others. But what makes a good map? How can we engage people with a map? How do we make a map that offers unexpected insights or even captivating beauty? Turning data into compelling map is about more than knowing which buttons to push. It's about knowing how to uncover stories hidden in our data. It's about telling those stories clearly and simply. ESRI has assembled a collection of good maps that we just love with information about why we love them and how they were made. Enjoy and explore digital maps and learn how we can make our similar maps of our own. A map can change the world. Maps We Love is an ongoing project to find and share inspiring examples of what's possible with ArcGIS. Our world is not flat, and maps don't have to be either. Viewing maps in 3D adds a new dimension to understanding and visualizing geography, where it's viewing things globally or in a city. Mercator projection merely brushes over the not so pretty bits of the map by stretching the parts of the Earth's surface out across the flat surface for a more aesthetically pleasing appearance to the map reader. USRI, headquartered in Redlands, California, is an international supplier of geographic information system software like ArcGIS, WebGIS, and geodatabase management applications. USRI pioneers problem solving with GIS through the science of where. USRI builds ArcGIS, the world's most powerful mapping and spatial analytics software. ArcGIS software and apps combine mapping and data analytics to deliver location intelligence and meet digital transformation needs for organizations of all sizes. The application of ArcGIS can be broadly classified into three categories: spatial analysis and data science, field operations, and mapping. Us to the power of maps. It's the highest spatial regionalization ecological land unit map of the world ever produced. ArcGIS Living Atlas of the World is the foremost collection of geographic information from around the globe, which includes maps, apps, data layers to support our work. The Living Atlas is the foremost collection of authoritative, ready-to-use global geographic information ever assembled from ESRI and the GIS user community. It's truly for the GIS community and by the GIS community. Anyone can export the Living Atlas. It enables the discovery of people, places around the world, as well as the natural and man-made influences that impact them. Always changing and evolving like our world does, the Living Atlas contains information that educates and informs. And this is some applications of ArcGIS Living Atlas. So from ISRS Kolkata chapter, we are giving this message that GIS is a scientific framework for gathering, analyzing, and visualizing geographic data to help us make better decisions. On GIS Day, we have to help others learn how about geography with multidimensional approach and the real-world application of GIS that are making a difference in our society. It's a chance for us to share our accomplishment and inspire others to discover and use GIS. GIS Day has brought educators and students, government agencies, non-profits, and GIS professionals together annually since 1999 to discover and explore real-world applications of geographic information system. Although GIS Day celebration looked a little different in this year 2020, the GIS community hosted virtual events for organizations, met online with schools, held safe gathering in communities, and much more. The GIS Day 2020 event has been uploaded in www.gis.com. And it's our immense pleasure that we have Dr. Partho Sarothi Chakraborty, the founder secretary of ISRS Kolkata chapter and former chief scientist, Department of Science and Technology, Government of West Bengal, as the chief guest of GIS Day 2020 program. I do welcome sir to join with us with this program. I do welcome an invited speaker, Mr. Shantanu Datto, Group Manager, Technology Solutions, ESRI India Private Limited. I do welcome 7 speakers from our executive committee members. Ms. Devaruti Das, Joint Secretary, ISRSK and State Aided College Teacher, PND Das College, Palta. Dr. Basudev Bhatto, Executive Committee Member, ISRSK and Coordinator, CAT Center, Jadavpur University. Professor Biplab Bishwas, Executive Committee Member, ISRSK and Professor, Geography Department, Bardwan University. Dr. Sreyoshi Sattanutto, Executive Committee Member, ISRSK and Assistant Professor, Civil Engineering Department, Haldia Institute of Technology. Dr. Mamata Desai, Executive Committee Member, ISRSK and former Professor, Netaji Institute of Asian Studies, Government of West Bengal. Dr. Shandha Bhaduri, Executive Member, ISRSK and former Deputy Director, NATMO, Government of India. And Dr. Tuhin Bhadro, Executive Committee Member, ISRSK and Assistant Professor, Adamas University, Barashat. I do also welcome all the participants joined virtually from different corners of India. With this, I am concluding my speech. Thank you all. Happy GIS Day 2020.
Thank you, sir. Thank you so much. Now, I would like to request our Honorable Chief Guest, Dr. Partho Sarothi Chakraborty, to deliver his Dr. Parthasarathi Chakraborty is the former Chief Scientist, Department of Science and Technology, Government of West Bengal, and former geologist, Geological Survey of India. He possesses vast experience in application fields of remote sensing and GIS in geological, applied geomorphological, and environmental geoscience. He has experience of working in India and abroad, namely the Netherlands, Italy, Nepal, Istanbul, and Bangladesh. His contributions has been acknowledged by the award of Dr. J. Coggin Brown Gold Medal in 1999-2000 from Mining, Geological and Geological Society of India. Also, National Science Day Award in 2007 by the Science Association of Bengal, Kolkata. In reading and GIS domain, his work are appreciated through award for the best research paper titled Land Evaluation, Geoinformation, Input for Land Use Planning in the International Conference Geoinformatics Beyond 2000, organized by IIRS Department of Space, Dehradun, and ITC, the Netherlands, in March 1999. He also received Bronze Medal Award of MGMI in 2000-2001, technical paper RS and GIS, Spatial Format for Sustainable Resource Development. Also, Best Paper Award titled Coastal Zone Management Eastern India by Society of Geoscientists and Allied Technologists, Bhubaneswar, Odisha, India in December 2018. Dr. Chakraborty became Fellow of Academy of Science and Technology in 2004 for his outstanding contribution in remote sensing and GIS applications. Dr. Chakraborty was an expert member of West Bengal State Pollution Control Board, and till date, he is acting as expert member of a number of advisory and expert committees of the state and national level. There are more than 70 research papers in his credit. He is the first author of the book Rivers of West Bengal Changing Scenario, published by West Bengal in 2015. He has also translated the ISRO publication Effective Use of Space Technology in Bangla as entrusted by the ISRO, released by the Department of Space in April 2018. Academic orientation reflects on his till date attachment with different universities of state and country, pertaining to member of Board of Studies, PhD committee, and postgraduate and PhD level teaching, guidance and examinations, as well as training courses of various academic institutes, departments, organizations on orientation for the societal development. Now, I request Dr. Chakraborty to deliver his speech. Sir, please.
Myself, Parthasarathi Chakraborty. I am audible to you all. Hello.
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes,
I am
sir.
audible to
You're
you
audible,
all.
sir. Yes, sir. You are audible.
It's a pleasure for me to be present in this evening webinar to celebrate the GIS Day organized by ISRS Kolkata chapter in collaboration with CAD Center, Jadavpur University. I have chosen a topic for this webinar, that is GIS Science and Technology for Developmental Planning. Specifically for the advanced students and researchers, those who are ISRS member or in the academic institutions. Now, how we will define the GIS? I have given three definitions. geographic information system, geographic information studies, and lastly, geographic information science. You can read very well. You can read the slide very well.
Sir, full
Hello,
screen. Sir, display
Yes,
in
sir.
full
full
screen,
screen.
please. Yeah, now
Now
it is
you are
okay. Yes, yes.
getting me, getting the, you can read well. Now that geographic information system, geographic information studies, and geographic information science. Out of these three definitions, if we consider the first two, then the definition of geographic information system will be a computerized system for collecting, storing, retrieving, and transforming and displaying the spatial data for a specific requirement or purpose. More specifically, integration and analysis of spatial and spatial data for user-oriented information. If you consider these first two definitions, where G stands for geography or that spatial data or georeference data, that is map, and information assigned to a spatial data in relation to the spatial database, not to be viewed as data acquisition only, but refers to data capture and analysis. And lastly, the system or studies which may be considered as a platform for that data acquisition, management, storage, and retrieval, and integration and analysis, which includes also the different softwares, including digital image processing for RS data, geostatistical softwares, table operations, etc., etc. Therefore, the core business of the GIS, it is the integration and analysis of the spatial and non-spatial data. Now, GIS, if we think otherwise, the GIS is the platform for data acquisition, transformation, management, and dissemination. I have already mentioned. But GIS is the technology which allows people to analyze problems in different ways with geographical representation of real-world scenario or reality obtained from RS data, the core of GIS. Secondly, GIS is a tool to facilitate convergence of two or more spatial data layers and related non-spatial or attribute data to conclude on application-specific strategic dataset. Perhaps the greatest attraction of GIS in natural resources, environmental and natural hazard management. In the present day scenario, open source GIS is another added advantage to the user community, as well as likely to play a major role in GIS education in academic institutions. Now, if we consider GIS as geographical information science, then GIS is actually having two distinct disciplines. Computer science that GIS is having two distinct disciplines. Computer science, especially for databases, computational geometry, image processing, pattern recognition. And another part is information science and technology, which includes subjects concerned with studying Earth, either in physical or human orientation. The subjects include from geology, geophysics, oceanography, atmospheric science, agriculture, forest and environmental science, geography, sociology, political science, anthropology, etc. And another one is outreach programs. Outreach programs like telemedicine and tele-education, etc. Now, what GIS actually produce? What GIS is actually producing? GIS is a simple information system, an information system which produces information for the user in terms of database that is factual and functional all the time, which is factual and functional all the time. And second one is best possible solution and answer to the user or users as per their requirements. Therefore, successful GIS will provide useful information to the user for fulfillment of the objective. Therefore, we should concentrate on user requirement, not on technology. The very perspective is to provide user-oriented data for what the technology is used. Therefore, what are the successful for successful GIS? What will be the steps? The first one is to identify the task. Identify the task which is provided by the user. Accordingly, GIS should produce the information. And now, which information is necessary for the task that you have to identify also, and which form of the information is easy to understand for the user. Lastly, what is the data facility or requirement that is for producing desired information, that is data availability as well as authenticity of collected data. Because when I first undergone the training, that time Survey of India, my teacher in Survey of India told garbage in, garbage out, that if it is not correct data which you are providing, then GIS will also provide incorrect information. Now, for nowadays also that there is heterogeneity in GIS because different departments use its individual system to increase efficiency, but sharing data and application across the enterprise is near impossible. And mixing of software and information system are to be compatible to each other for extended use, that is OGC or OpenGIS Consortium. The issues related to resolve the above mentioned issues to be resolved by number one, making data description homogeneous. Number two, standard encoding for data. Standard encoding for data, that is georeferencing, data format, structure and quality issues, semantics and content issues. And lastly, the standard mechanism for data sharing. In the present day context, the architecture, the service-oriented architecture of the GIS, where a service means well-defined set of actions, self-contained, stateless, and does not depend on the state of other services. Stateless means network protocol in which client interacts with a server and action is performed and server responds back as per the given state. Very promising for practical implementation of GIS, where GIS services are specifically involved in data service, processing service, and catalog or registry service. this development sequence, which time the development sequence of GIS or sequence of development of GIS in the present framework are, if we enlist it, then we will find first enterprise GIS with customized decision support tools to facilitate integrated analysis of different datasets and their visualization. In this context, I like to mention the name of Dr. AMJ Meijering of ITC Netherlands, who first made the GIS software for our earth science integration and analysis data of earth science and earth science, that ELUIS software. That ELUIS software, which was originated by him in the year 1987-88, when I was in ITC for this particular training. And next is OpenGIS Consortium to create a consensus process for addressing crucial interoperability issues, collaboratively maintaining global standard. And lastly, for the present day, WebGIS or Spatial Web Service, a continuation of OGC, web-oriented geospatial applications to support ICT, the information and communication technology, which facilitate customized mobile applications, smartphones, for domain-specific attribute data collection with geotagging and ground photographs, nowadays specifically used during the natural hazards disaster management, as it has been done by ISRS. It has been done by ISRO for Himachal Pradesh disaster and UP disasters also. Now, I am not going to elaborate the enterprise GIS concept, but main thing is that a GIS, enterprise GIS, a GIS that supports application which are easy to use and understand. Easy to use and understand. And here you can see one conceptual framework of database creation on that with this concept, that is the educational institutes in one of the districts, that is Bardhaman district, Paschim and Purbo Bardhaman districts in West Bengal. Here, all that database contains all the individual block wise, and if you take one block, Asansol, and here you can see the number of academic institutions, whether engineering institute or your degree colleges or university, etc., etc. And if you take this spatial one in this spatial database of Asansol, where all these are marked, then you can, if you click it, then you will get the details of that particular academic institutions. Actually, this is one part of one project of educational information system of the DST government of India. Now, that OpenGIS consortium, here that OpenGIS consortium is actually initiated in 1994, and commitment of the OGC is the development of the open software interfaces, encoding and best practices, and OpenGIS specifications that enable different vendors, software systems to communicate and facilities integration of the different types of geospatial information. This ubiquitous access at any time by anybody to all geospatial solutions and information. The most OGC standards have been developed in the web environment or web GIS in the present day context. And presently, OGC not only play very actively as a part of mainstream ICT as we are doing this webinar, but also act as a unifier of various technological disciplines related to the future geospatial processing, for example, engineering, construction, logistics, etc. Now coming to the relationship between RS and GIS technologies, not RS and GIS technology. Here there are two different technology, RS and GIS. RS is base information system, GIS is platform table technology. Now the thing is that why RS is important for core of GIS? Because RS, remote sensing, provides us the up-to-date spatial data of the Earth surface and the related matters. And now another thing is that and GIS platform where we are harmonizing and standardizing that spatial data, RS data, and the related spatial data to frame decision rules with specific perspective and accordingly output in users orientation. However, there are number of error sources as in different error sources for this procedure. Now, I have mentioned two formal data structure of the GIS, out of which there are two formal data structure, that raster and vector. And raster is here you can see the raster grid pattern, and the vector is area, point, and line features. Now raster, our RS data is in the raster mode. When we are interpreting the RS data or one map data or RS data for mapping, then we are converting it into vector data, and with that area, point, or line features, here you can visualize that same thing in the easy to understand way. Now some examples from my work when I was in the actually in the working mode in our department's GSI or that State Remote Sensing Center DST. Here simple overlay of maps. This is a simple GIS where we have overlaying the 1975 toposit data on the present day on the 1997 image at Farakka, upstream of Farakka area in West Bengal. Here you can visualize what is the difference, and easily you can identify the areas where it has been changing course, where is the change in the river course. And this is also another example of Dwarakeshwar River of different time sequence. By that way, why it has been done? It is having to prepare some strategic data set for what? That is your lift irrigation problems. Lift irrigation problems, because with the shifting of the rivers, lift irrigation points to be shifted, and for the reason that map has been prepared, and this here also we have done that time the simple GIS. And here you can visualize some images of the Rangat Bay area of Andaman. Here pre-monsoon and post-monsoon. If you see the color of the, and here is the topo part of the topo map of 1980, and these are the pre-monsoon, pre-tsunami, and this is post-tsunami. You just concentrate on this part, and if you see the difference in color of these two images, why RS is required for GIS. Now from that, we have prepared two maps, land use, land cover, and another geomorphological map. From that, you can identify the areas where in this geomorphological, this is the area which has been damaged by the tsunami. Here is the land use map, and these are the portions where damage is more. And this from the toposit, we have taken that your high water line, earlier high water line and the present high water line. Why this portion is damaged? If you see earlier slide, then you can see the color difference between these two. And why this difference, damage? This damage, you see that people, they have the inhabitants, they have encroached the natures, encroached that human encroachment on nature's own built system. They have encroached the mangrove swamp zone with by that reclamation, by doing reclamation, they have done that guava garden, etc. This is the another example. And now coming to the engineering field, now for infrastructure planning, for your rail, road, power transmission line, gas pipeline, etc., for development and plannings, urban and rural, site suitability analysis that we are using nowadays, that GIS with what I will tell, we are regularly using it. And now modernization of land records, that is also done with high resolution satellite images. And here you can see one overlay of parcel map on the image of 2007 of the Borjura Gram Panchayat of Bankura district. And another thing, that shoreline shifting, natural hazard shifting, where we are using that parcel map to know how many parcels has under erosion. By that way, you can see that both that field here, it is a Jatranala area, and where this is the image, and this is the field photograph. And another example, side of the Digha sector, that is Chandpur sector, or your near to your that what I will tell, that Bijnu Chandpur, it is nearer to your that Tajpur. And here you can see that how that erosion is going on and encroaching the different parcels. And here you can see that field photo of the Blue Lagoon Hotel, which is here. This is Tajpur area, Chandpur, and this is Jalda area. And presently we are doing also asset mapping. It is a snapshot showing asset mapping points over 25 lakh houses. That is from the ISRO, which ISRO has done with AP Remote Sensing Center. And very recently, or not very recently, 2 years already over, that we are using GIS for election purpose, our general election, and that is here for the assembly election or for the parliamentary election, where different parameters of each polling station, etc., are taken, and visualization of the hierarchy-wise district assembly polling stations data are also maintained. And accordingly, with this mobile smartphones, now they are monitoring it. That is the ICT, which I have already mentioned earlier. Now, namaskar. Thank you all for questions, for hearing me with full. Thank you all. Thank you all.
Thank you, sir. Thank you so much. That was really informative and helpful for the entire GIS community. Now, there's a small announcement that I want to make. This is to inform to all the participants that we shall send a link to email address tomorrow to submit a review. Please submit the review within 30th of November 2020. The certificates will be mailed to you instantly once the reviews are. Now, we are going to proceed to the technical session of today's webinar. Our first distinguished speaker for the technical session is Mr. Shantanu Dotto, Group Manager, Technology Solutions from ESRI India Technologies Private Limited. Mr. Dotto is going to deliver his presentation on convergence of geospatial technology for AI, ML, AR, and IoT. Sir, please.
Thank you. Hopefully my screen is visible to you all.
Yes, sir, it is visible.
Okay, thanks. So thank you first. Happy GIS Day 2020 in a virtual mode to all of you. I'm very pleased to, I'm happy to share the today's some sort of the idea and some sort of our experience on the GIS with AI and ML and AR and IoT with you all. And I'm very much thankful to ISRS Kolkata chapter, Jadavpur University CAD Center, and all other members who has joined. As Subroto sir has already set the tune and Parthasarathi sir has briefed in detail and very detailed and excellent way. So from there, I would like to just take it in forward and to talk about how currently what we are facing, where we are, and how GIS is helping us in daily life. If you think today we are totally in a complex world where we are interconnected and also we are fighting with nature. There are lots of things, lots of problems are coming. Maybe it's a pollution, maybe as we are into this pandemic disease we are facing now, the pollution is a major issue. So deforestation is happening, the urbanization, urban encroachments are happening. So it is constantly changing. So when it is changing, obviously the world, the nature is getting changed. Everything is getting changed and we are facing huge issues nowadays. So when we are facing these all issues, we need to understand, we need to collaborate, we need to take some step, we need to make the action. So how GIS can helpful for us? Nowadays, if I'll take the current situation, we are facing this coronavirus, this particular pandemic disease. Every day we are looking for where is the COVID center, where is the COVID hospital, where is the testing centers, where I am, where is my containment zone, whether I am the containment zone or not. If I am going to some place, so either the people, anyone was affected few days ago or not. So whatever I am doing, whatever I am thinking, whatever I am talking with someone, everywhere where this particular term is utilizing. So now everywhere nowadays we need to think about the digital geography power we are feeling, which is helping us to create a sustainable development. We are helping us to engage ourselves. We are providing informations. We are also trying to protect the biodiversity. And then when we are doing all these things, geospatial infrastructure, as Parthasarathi sir was telling, is very, very important, where we are not a single entity. Now our team is working. You can see in this current COVID situations, there are several departments is working, health department working, local governing authority, local administration is working, police department is working. Everyone is working for a single objective. So everyone is working for to identify only a question, that is where. So everyone is working for GIS. So now GIS is at scale, which is interconnecting all different distributed services together. And obviously when we are working for different distributed ways, there are different data we are using. That data can be from the open data, someone is using some sort of the COTS platform or some sort of the customized data sets. Someone is using big data, someone is using some IoT sensors, services, artificial intelligence tools and technologies are coming. So there are lots of rich network of distributed contents that are coming together nowadays, and this helps us to utilize it to see the output. So output for planning purposes. You can take the reference as your current situation. We can plan for to eradicate the COVID. We can see the operation. We can monitor the situations. If someone I am taking, we can also monitor the total scenario every day in a 4 o'clock. Our honorable health minister of health and family welfare, he brief about the situations to the media, and all media personnel talks about the dashboard. Why? Because we are monitoring. The decisions are getting taken. So when these all things are taken together, we are also working for the latest innovations and all. We are working for artificial intelligence, machine learning. We are working for the distributed architecture. We are working for the SOA architecture. Parthasarathy sir was talking about that. We are working for the open science technologies and all. So all things are taking together nowadays, and you need to focus for the three fundamental systems. One is system for insights, where we are doing the analysis. We are doing spatial analysis. We are doing geostatistical analysis. We are doing network analysis. Simultaneously, we are serving the users or serving the citizen as an app. We are very nowadays we are very much friendly to handle the Android based mobile. So apps and maps are very familiar to us. The system of engagement where the apps and maps are playing a huge role, and simultaneously the sensor integration, the real-time data integration, and system of record. So these things are coming together, and most of the times now we think about cloud platform. We think about to utilize these all applications in a cloud. Maybe it's a Kubernetes, maybe it's a Google, maybe it's a Azure, maybe it's any other cloud platform. Those can be taken together. Those can be utilized, by which we can deploy the platform. We can take the output from there, and also parallelly we need to think about the open platform. It should not be only open source. It should be open platform. Parthasarathy sir was highlighted very accurately the strength of the open source or the open platform. It should be. It has to be. Then only nowadays the situation where we can fight. We can integrate any sort of the data from any format. We can integrate any application. We can provide the data to any platform to utilize it to any other. Some of us are very keen to any statistical platform, the Python, the Pandas, the PyTorch, the machine learning tools and functionalities. All should be customizable, interoperable, and flexible. Then only we can take it together. We can take it different data sets, unstructured data. This is a very unique data sets we used. Maybe when we are collecting data from field, most of the times we are not collecting the coordinate. We are collecting only the name of the place. But we can convert that thing as a spatial feature, as an unstructured data handling, tabular data, multidimensional data, which is the latest utilization in the geospatial industry now. Handling of multidimensional data, maybe for the bedrock, maybe for the aquifer, geological analysis, geomorphological analysis, or the climate analysis, everything for the multidimensional data analysis, real-time data, 3D, vector data sets, imageries. These all are coming together in a geospatial infrastructure, and output is going as a web map, as a mobile application, as any kind of application. So when we are talking all these things together, now the machine learning, artificial intelligence, and deep learning, this is a new technology. This is a buzzword in today's industry. Maybe from the last 5 years or 10 years, we are very much familiar with different kinds of tools which are under this technology now, maybe for the classification, maybe for clustering, prediction, object identification. But now what is happening, system is integrated, system is generated automatically with the codes, with the tools, with the different frameworks and platforms, and that is automatically helping me to identify any object, to identify any feature from the imageries. It's also helping me to integrate any other open source based functionalities like TensorFlow, like PyTorches and all. And simultaneously it will help you to work with the prediction, maybe for the classification, maybe for the clustering analysis. You can do any kind of the predictions. You can do if someone is working with the crime analysis or traffic analysis, traffic accident predictions, you can do the suitability analysis, suitability modeling, classifications, any kind of the random tree classification, vector machine classifications, also simultaneously for the clusterings. These specific clustering tools is very used in last 5 to 6 months. We are very familiar with the terminology called contact tracing. Due to this COVID, we are very familiar with the place-based contact tracing, human-to-human contact tracing, identify of the zones, buffer zone, hotspots was created for that. The containment zones were created for that. So this is the technology which is helping us to combat in this scenario, where the GIS is helping with the machine learning and helping for any field, helping for agricultural yield, change detection, fleet management, precision agriculture, And also the machine learning tools are working for the regional planning, simultaneously flood planning, land cover classifications. And we are also focusing for the deep learning tools simultaneously for other aspects, like in the defense, to identify any unidentified objects from the imagery, environmental compliances, land cover classifications. These are all the areas where AI, ML, and deep learning is using a lot. To do this in the backend, there is a strong spatial analytics system you have to have, and that system helping me to do these things, helping me to do the spatial analysis, helping me to do the processes. The Python tools are getting integrated, and Python based processing I am doing. I am creating converting models, and the Python channels, Python tools I create and integrating and run it. Forest based classifications I am doing. So the strong spatial analytics and data science is working for that. Simultaneously, the next approach is real-time data, anywhere, any sector. Last couple of weeks, last couple of days, when I was going to the paper, I was observing this is not only the current situation, the stubble burning, the waste of the agriculture, which is going to be burned by the farmers for the next round of agriculture activity, which they want to do in the same place. So that stubble burning is a major issue now, which is giving an adverse effects to the pollution. So the environmental sensor data integration, real-time data from camera traffic feeds, integration of that, disaster management. If I'll talk about the disaster, the rain gauge data, the telemetry data integrations. So all these real-time data are getting integrated. If I'll talk about water utility, the SCADA getting integrated nowadays. And when these are coming together, the IoT is playing a major role. IoT is having three components: Edge, IoT platform, and IoT enterprise. So if I'll brief in this thing, IoT Edge is basically the passage or the ways from where the data are coming. IoT platforms, that are some of the times it is hosted into the cloud, which is consuming those services directly from any sort of the sensor. And after that, the geospatial platform is directly integrating those services from the sensors, and it is giving the reflect onto your map to give the alert, maybe for the floodgate, to give the alert maybe for the environment, to understand what is the current scenario. So these all aspects. So here the IoT platform and enterprise working together, IoTs are working together with the GIS, and it is continuously, it is taking to the edge. It is giving service to the user, right? The real-time measurements, like I can identify the crack of the pavements or crack of the road using the machine learning or the IoT technologies. That is happening now. The next technology, which is we are very, very popular, is an augmented reality. Now, in a real-time scenario, we can analyze, we can see the current status, we can visualize the current scenario with if any sort of the area. So if you will see in this particular video, we have tried to capture the realistic view of an university inside of the augmented reality. The augmented reality application has been integrated with the GIS nowadays. So based on that, you can visualize, you can plan, which is most important. You can plan your establishment, you can do the development, you can utilize your land, and you can also take the decisions for investment, for any sort of the other development activities. So these are the strengths where an university has integrated the augmented reality and the virtual reality with the GIS, and they have started to utilize that thing for their planning and for their utilization purposes. Same way, there is more growth is going on for the field operations. The data are getting collected from the field. Data are getting, nowadays we are very familiar with the apps and mobiles and all. So mobile based data collection process, which helps us to minimize the data redundancy, to minimize the data migration effort, which helps me to automatically convert the data to a central system from where I can utilize it. The field operation is nowadays, it is totally mobile based, where it is not only collection of data, but also I can monitor the team who is collecting the data from the field. I can monitor where he is going, how much data he is collecting from the field, which is helping us to do the tracking, to do the offline workflows or the pre-planned routings and all. So there is a small application where recently for the Indian Urban Observatory, Government of India, Ministry of Urban Development, ESRI, has launched a pan-India basis application where several IoTs has been integrated, several for different domains. For maybe it's for the solid waste, maybe it's for the air quality, mobility, lightnings. It has also given the data or the solution to different cities for the smart city activities, and also for the sanitations, for the perspective views, the traffic informations. So it's a single uniform place from where the all informations are being provided to the as a configurable way, without development, without anything, just for a service you can provide and user can utilize it. The same way, there is another implementation which we have recently done, that's called the Gurgaon One Map, where again the government, the state, the Gurgaon City Development Authority has implemented their city level GIS system. Very familiar, very popular nowadays for any national schemes are going on for our students, like the Amrut, like smart cities. There are several huge amount of recruitment is happening in those areas also. So these are their focus, where they are developing different applications under Amrut project, under Smart City project, under Swachh Bharat project, under our agriculture project, PMKSY project. So these are the strength, these are the areas where the geospatial technology is integrating. And these all AI, ML, AR and IoT, if I'll think about the application area, the most important nowadays situation is healthcare, where we in last 5 or 6 months we have understood the strength of GIS, the disease surveillance, the mapping of the facilities, the planning of the mobile health services, where is the mobile health service can go, the epidemic analysis, emergency response systems, community at risk, or the epidemic spread, what is happening, or the availability of the medicines, the health workers. Everywhere the geospatial technology and the geo AI is integrating and utilizing. These are some of the application areas where recently in last couple of the days, couple of months we have done, like for the John Hopkins University, or for the Punjab, or WHO, or FEMA, or there were several states, several governments, several countries. ISRI has worked with them to combat with the COVID itself. And parallelly now, our responsibility hasn't been finished. Now we have started working for the next line of approach, that is vaccine distribution. Now we have started working with the Ministry of Health and Family Welfare, how quickly, how in a good way we can distribute the vaccine still to the rural people. So GIS based vaccine distribution system, that we have started working with the Ministry of Health and Family Welfare. Simultaneously, the facility preparation everywhere has been opened. So space management, density analysis, situational awareness, and the supply chain management. We need to think about that. Our economy has degraded in the last 5 or 6 months, that we know. So we need to increase our economy. So the material outsourcing, distribution, all things are now GIS based under this business continuity for the post lockdown. So these we are focusing utilization of the Geo AI. The Geo AI again is utilizing for the agriculture now, very focusedly. Government of India is focusing a lot for the cropping pattern, yield assessment, crop health monitoring, for also the fertilizer requirement, pest monitoring, even utilizing drone and utilizing the machine learning, identifying the health of the tree. And also the water resource. This is another major focusable area where the water quality monitoring we can do. We can do the water harvesting, water treatment, water conservation, check dam assessment. And when I'll think about the utility, there is again the integration of the SCADA, again the integration of the sensors to create a city level water distribution maps where the IoT plays a major role. Same way for the transport. Nowadays, machine learning and this real-time data analysis is very much using for any sort of the transport departments. Nowadays they are focusing for the identifying the pavement cracks, because we know that PWD's responsibility is to maintain the road, is to manage the road. Most of the times they have to do the survey, then they take the data, or else they want to take the data from high resolution images. Some of the times the potholes are not getting identified from the images, they have to do the survey. But now using machine learning, if we will drive a car on the top of a road, automatically from the camera, those scenes can be taken into the geospatial platform, and utilizing the different notebook server, Python, PyTorch, or any sort of the open source tools or the open platform tools, we can easily identify the potholes or the pavement tracks on the top of the roads, or on the for beneficial for the management of the transport department. This is a major area of the utilization of the transport nowadays. Simultaneously, for the homeland security, this is again an important area of the artificial intelligence and machine learning to identify the crime prediction zones, to identify the traffic accident prone zones, to identify in which area is most crime prone. So these are all the areas, analytics, these are all those areas and all the use cases where nowadays the geospatial technology, specifically for the machine learning technology or specifically for these IoTs, are getting integrated. And autonomous car, this is another area where it is not that much of the familiar in India nowadays, but abroad in US and in Canada, ISRI is working lots of the projects with the mapping and monitoring and managing of the autonomous cars, which is self-driven, to monitor that thing, to monitor its road, to monitor the density, everything altogether. So like this is an example of in Toronto where a car density is getting monitored, which are all the autonomous cars density. So this is all together application areas. This is all together the different places where the geospatial technology is now working with solely with the machine learning, artificial intelligence, and IoTs. And if you will see in the current scenario in today's world and today's pandemic scenario, every day we also feel that the location information is very important, and we are trying to integrate these all and trying to utilize these all applications and tools to combat with this situation. So thank you from my end.
Thank you, Mr. Dotto. That was really an amazing presentation. Once again, I would like to inform to all the participants that a link will be sent to your email address to submit a review. Please review within 30th of November 2020. The certificates will be mailed to you once you submit your reviews. The next presentation will be delivered by our distinguished speaker, Ms. Debarati Das. She is the Joint Secretary of ISRS Kolkata Chapter and State-Aided College Teacher, PNT College, Polta. Dash will give a presentation on how does GIS work. Ms. Dash, please.
Good evening all. It's an opportunity for me to present in front of this August gathering. Today I'm going to talk on how does GIS work. GIS is Geographical Information System. It consists of spatial and attribute information by definition as given by Earth Data NASA. GIS is a collection of computer-based tools for organizing information from a variety of data sources to map and examine changes on Earth. Components of GIS. GIS has few important components as hardware. It is the computer system on which GIS software runs. Software, for example, ArcGIS, ArcView, MapInfo are used for analysis of GIS data. Procedure, it assists in data capture, storage, processing, analysis, modeling, and display of geospatial data. Data, geospatial and attribute data are essential input for GIS. Geospatial data consists of latitude and longitude, whereas attribute data consists of additional information about the given object for which latitude and longitude is being provided. Users are pivotal part of GIS. Raster data, it consists of pixels which store digital number. This digital number varies from 0 to 255 for 2 to the power 8-bit data. Raster data have become the primary source of geospatial data in geographic databases. Raster data is being represented by different features. For point, feature by single cell. For line, by sequence of neighboring cells. Polygons, by collection of contiguous cells. In this picture, a real-world data is represented in a raster data format is shown here. In a real world, the houses are there which are shown in 3 pixels in the raster data. In the real world, a water body is there which is also represented by W, which is being coded as for water, and it occupying 4 pixels. For forest, it is also occupying few pixels, and river, which is a linear feature which is going through the total real world in this map which is being shown. In the raster data format also, the river, the linear feature, is going through the middle of the area. Vector data, GIS uses this vector data immensely. It is represented by point, line, polygon. For point, we have 1x and 1y. For line, we have multiple x and multiple y, but for the starting point x and y is different from the terminal point x and y. In polygon also, we have multiple x and y, but starting x and y is similar to the ending x and y. Polygon is a bounded area. This portion is showing the area for which we are bounding a particular object. This picture will help to understand the raster data model and vector data model. In the vector data model, a point is shown in XY coordinate, and in the raster data model, a single pixel is being colored representing that point on the vector data. Same way, a linear feature is being represented as line with multiple x and y, whereas in vector data, it is shown with highlighted pixels. In vector data, a polygon is used to show a bounded area. In raster data, the pixels are highlighted to show a bounded area. In this picture, the real world is shown as well as how it is represented in vector and raster data are also shown. In raster data, real world is shown with the help of the pixels, whereas in vector data, different layers of different land use pattern are created and then they are superimposed upon each other, and a final version is being created where we can find all the land use as we find in the real world. 3 views of information system. We have database view. It is an information system of geography. It is an important part. It is a repository from which coming people who are going to work on a particular area and on which the database is created can use them. Map view, here intelligent mapping is being done, is being created for better understanding of the area. Model view, 3D model of a particular area is being created for better managing of the area. For example, traffic modeling can be done, smart city modeling can be done. Areas of application. As we know, GIS is an important tool in understanding and managing the earth and its environment. So, for doing that, GIS is not restricted to any particular subject. It has percolated and it has its imprint in every discipline. In agriculture, it is used for managing crop yield, monitoring crop rotation, as well as for projecting soil loss for individual areas as well. Business, it is a tool for managing any kind of business. Information according to location. In business, the orders can be delivered to the person in a better way with the help of GIS. Electric or gas utilities, GIS helps to map different utilities, and with this GIS, the tracking can be done, and where the maintenance can be found can also be tracked. Environment, GIS is used to prepare map, trace pollutants, find the degraded area, make areas which can be preserved, and take decisions according to the maps prepared. Forestry, to manage forest, GIS has become an important tool with which forest degradation over the years can be prepared, a map can be prepared. If there is a problem of forest fire, as we find in Dehradun, that can also be solved by using GIS. Geology, it is used to study the geologic features, analyze soils and strata, assess seismic information, and create 3D features. Hydrology, it is also important, as in hydrology, we can prepare maps on groundwater quality, groundwater depletion, groundwater gradient. Land use planning. Land use planning maps are being created by GIS in rural and urban areas for better utilization of the available land and better planning for the coming generation. Local government are using GIS as an important tool to provide better service to its citizens. Military, in military services, GIS is being used immensely to combat the attack from the enemies by preparing base maps, terrain maps, and so on. Transportation. In transportation also, GIS is being used by finding out the best route to reach the destination. An example can be cited here. While traveling in Ola or Uber, this GIS shows us the route to our destination. In engineering also, GIS has its imprint. It has been immensely used nowadays to prepare maps for better understanding of the area. Risk management. In risk management also, GIS helps people. If we can prepare disaster map of an area, we can easily save the loss of property and life of a disaster-prone area. These are the references that I have used to prepare this presentation. With this, I would like to say thank you for your patient hearing.
Thank you so much, Ms. Dash, for such a delightful presentation. Now, I would like to request Dr. Basudev Bhatto, Executive Committee Member, ISR Chapter and Course Coordinator, CAT Center, Jadavpur University, Kolkata, to deliver his presentation on GIS data capturing techniques and integration of remote and GIS. Sir, please.
A very good evening to all of you. I'm going to discuss GIS data capturing techniques and integration of remote sensing and GIS in brief. The power of GIS comes from the ability to relate different information in a spatial context and to reach a conclusion about the relationship. Most of the information we have about our world contains a location reference, placing that information at some point on the globe. A GIS, which can use information from many different sources in many different forms, can help with various analyses. The primary requirement for the source data involves knowledge of location for the variables. The data sources for data acquisitions should be carefully selected for specific purposes. The data sources for GIS can be categorized as conventional analog map sources, aerial remote sensing, satellite remote sensing, field data sources, for example, surveying for attribute and GNSS, reports and publications, and existing digital map sources. Topographic maps with contours and other terrain features, cadastral maps and thematic maps with respect to defined object classes are digitized by digitizers manually or by scanners. Although analog maps contain several problems like lack of availability, being out of date, inconsistency in map production time, inconsistency of map scale or projection, inaccuracy, etc. But these maps are still very useful data sources for GIS projects, especially in low-cost GIS projects where high costs prohibit the use of current high-resolution remotely sensed data. Aerial remote sensing or aerial photography was the first widely used method of remote sensing. It is the technique of capturing imageries from some air platform. These images are used for obtaining information about object, area, or phenomenon. These data are used in GIS as a background for other data to provide a spatial context to those data and to aid interpretation. Alternatively, the user may extract information on land use, vegetation type, or any other aspects of landscape from the aerial remote sensing data. Three-dimensional information about the Earth's surface can also be obtained from aerial remote sensing using classic photogrammetric techniques. Other than the stated classic aerial photogrammetric techniques, aerial remote sensing is now widely being used for hyperspectral, thermal, and LiDAR data collection from the aeroplanes. Drones are a new addition in remote sensing that can be used to capture optical, thermal, and LiDAR data from a low altitude and thus with greater level of detail. Needless to say that LiDAR can provide 3D point cloud. That is perhaps the most advanced data included in GIS. 3D point cloud can also be created by traditional photogrammetry and by processing the optical drone images. Satellite images are collected by sensors on board a satellite and then relayed to the Earth as a series of electronic signals, which are processed by a computer to produce an image. Satellite remote sensing has the ability to provide complete, cost-effective, repetitive, spatial, and temporal data coverage, which means that various phenomena can be analyzed synoptically, and such tasks as the assessment and monitoring of land condition can be carried out over large regions. With the advent of high-resolution satellite-borne sensors, satellite images can also be used for mapping Earth's surface features in a great detail. The 3D information about the Earth's surface can also be obtained from satellite imageries using photogrammetry or radargrammetry techniques. There are several methods of collecting raw data in the field for direct input into GIS. These are most often used when the required data do not exist or any other readily available format, such as conventional map or remotely sensed imagery. Traditional manual surveying techniques using chains, plane tables, labels, and theodolites are examples for direct field measurement. Modern digital equivalents of these manual techniques have been adopted so that data are collected and stored in digital format, which are ready for direct input into GIS. Examples include total stations and handheld laser rangefinders. Apart from this, global navigation systems or GNSS are also used for field data collection. The GNSS involve satellites, ground stations, and user equipment to determine positions around the world. Various types of attribute data are also surveyed from the field and fed into the GIS. Socioeconomic data are usually listed in the reports or statistics and census with respect to administrative units. These are also known as conventional attribute data. In short, these are the data that can range from unpublished dissertations to published books, for example, census reports, town planning reports, etc. In the recent days, a change occurs in the transformation of data into a GIS database. Originally, most of the spatial data were derived from analog maps and remotely sensed images. However, a large amount of spatial information is now distributed in digital vector map formats. So, there is a wider use of existing digital map sources. Images or raster maps are widely being used in GIS analysis. Nowadays, significant amounts of open geospatial data are available on the internet. Open data means it is downloadable from an authoritative source for any type of use, reuse, and redistribution. Integration of GIS and remote sensing is the final topic I'm going to cover. It is not a new concept, although remote sensing is much older than GIS. Since its inception, GIS uses remotely sensed images as a major source of data. Nowadays, GIS and remote sensing are spoken about in the same breath, as they can revolutionize the concept of spatial data analysis and visualization. Combination of data of different types from different sources, such as those described earlier, is the pinnacle of data integration and analysis. In a digital environment, where all the data sources are geometrically registered to a common geographic base, the potential for information extraction is extremely wide. This is the concept for analysis within a digital GIS database. The integration with GIS allows a synergistic processing of multi-source spatial data. Any data source which can be referenced spatially can be used in this type of environment. A digital elevation model or digital terrain model is just an example of this kind of data. Other examples could include digital maps of soil type, land cover classes, forest species, road networks, and many others, depending on the application. The results from a classification of remote sensing dataset in map format could also be used in a GIS as another data source to update existing map data. Map products derived from remote sensing are usually critical components of a GIS. Remote sensing is an important technique to study both spatial and temporal phenomena, and it is used for monitoring. Although the analysis of remotely sensed data one can derive, although the analysis of remote sensing data, one can derive different types of information that can be combined with other spatial data within the GIS. The integration of two technologies creates a synergy in which the GIS improves the ability to extract information from remotely sensed data, and remote sensing, in turn, keeps the GIS up to date with actual Earth surface information. As a result, large amounts of spatial data can now be integrated and analyzed. This allows us for better understanding of environmental processes and better insight into the effect of human activities. The GIS and remote sensing can thus help people arrive at informed decisions about their environment. Like in all models, however, both maps and thematic data are abstractions or simplifications of the complex real world. Thus, it is important to realize that GIS and remote sensing can complement but never completely replace the field observations. Therefore, to conclude, the appropriate approach is to integrate remote sensing, GIS, and field observations in a common denominator, so that the maximum possible information can be accumulated and analyzed with maximum possible efficiency and reliability. Thank you for observing my lecture.
Thank you, sir. That was really an informative arrangement. Once again, all the participants are requested to submit through the link that will be sent tomorrow to the respective email addresses. You are requested to submit the review within 30th of November 2020. Once the review is submitted, the certificates will be mailed to you instantly. I would now request Professor Dr. Biplab Biswas, Executive Committee Member of ISRS and Professor of Geography Department, Bardhaman University, to throw some light on data incorporation and visualization methods in GIS. Dr.
Okay, thank you so much. I think I am audible to all of you. Good evening, everybody.
Yes, sir. Absolutely.
And this is really a proud moment for me, and I am privileged for delivering this lecture before this August gathering. I address Professor Dr. Parthasarathy Chakraborty and all other dignitaries in this gathering. And my presentation is data incorporation and visualization methods in GIS. So my previous four speakers have already discussed a lot about GIS and their structure, their types, applications of GIS, you know, sometimes the sources. So they made my task much easier. And so thank you. So my presentation, today's presentation, I have very simple three objectives, importance of GIS, most of the importance already covered by previous speakers. And this may be the new thing, the few fundamental open sources of geospatial data and visualization methods. So one interesting part, what I have noticed from the first speakers, Dr. Parthasarathy sir, Mr. Datta, and of course Dr. Bhatta, all they talked about open source, you know, OGC, open sources data, open sources softwares, so many things. So mostly I also thought about the same line, what are the open sources of geospatial data. So I would be talking much about that thing. So the definition of GIS is known to us, and it is beautiful that Partha sir has discussed the definition of GIS from various aspects, from science to system and studies. So that was the beautiful, presentation. And to make very simple, what I think, what is my personal opinion, GIS is simply linking information or data with location for visualization, analysis, and decision making. That is the fundamental aspect of GIS that I believe in. Okay, and so what we do in GIS, we prepare a map and we evaluate those maps, and we do act accordingly. We take decision accordingly, we analyze and act accordingly. So rightly, as Mr. Datta said, GIS is being applied in our daily life, whether we understand or don't understand, but we are applying GIS in our everyday life, being in riding Ola, Uber, or asking food from Swiggy, Zomato, or giving order to Amazon, or so going somewhere by driving some unknown road, unknown place by locating and giving the idea where we are going. And of course, nowadays, as Mr. Datta said about COVID and other situation, where is COVID and where there is the concentration and other things. So unknowingly or knowingly, we are applying the GIS. Okay, so basically when this internet was evolving in the beginning, we have heard the word e-governance. So E was internet or electronic something, and the governance, how the administration took decisions and applied their decisions. So that was e-governance. But now that E word has been replaced by the word G, letter G, that we say about G governance, or that is governance with GIS. So GIS is everywhere in everyday's life, everybody's life. Every planners, all kind of planning activities they are using GIS, and of course the business persons, strategists, everybody are using GIS. So this is a very brief list. Ms. Das has already discussed in detail about the applications of GIS. So this is the mapping of natural resource mapping, and general thematic mapping or static mapping, some mapping of some data. We do use GIS. For using GIS, we do natural resource management, disaster mitigation and management, environmental impact analysis, agricultural, thousands of agricultural applications, several more applications in urban planning, transportation planning, telecom and network services, accident analysis. That is, somewhere we are driving across the road and some notice board or board, it is signboard, it is there. So this is a accident prone area, be careful about that. So how do they come that this is accident prone area? Because they do analyze the accidents, events of accident, and locate those accident events on space, on geographic locations. So in that way they analyze, they say about the hotspot analysis, and of course navigation, just we talked about, and banking, taxation, surveying, whatnot. So everywhere nowadays we are using very intensively the GIS. So now, as I was talking about, I will be discussing about the open source software. So as Dr. Bhatto was telling about open source is a beautiful concept, So many a times we purchase open source. I mean, we cannot purchase the software, or we cannot purchase the data. That is really costly. If we purchase the ESRI or softwares, those are really costly. So but to continue the research work, we have the option to use open source geospatial data and softwares. So there are a huge number of data sources or softwares are available. And most importantly, as we know, our Bhuvan, our NRSC, National Remote Sensing Center, Government of India, they have our Bhuvan portal, and from there we can download a huge number of data, thematic services and real-time services as well, warnings and other things about cyclones. Everything we can get from Bhuvan. And we have natural art, that is a public domain for vector and raster data sets. We have global map, which provides global land cover data, UNEP environment, which gives forest cover, global potential evapotranspiration, temperature, fall, dams, Aster Dam, topographic analysis. And we are also having open topography, whatnot. There are a lot of data. Biodiversity hotspot, those who are interested about doing this biodiversity conservation, they can do biodiversity pilot analysis of global ecosystem. So ecosystem data, soil data, land use, land cover data. It is historical. You say somewhere you can get historical data from very long time, how this agricultural land use, land cover, agricultural land is being changed in their percentage of coverage. We can get that historical data. And historically, you see cropland data starting from 1700 to 1992. You can have documented data. So free, these data are free and open. You just can download that data for your research, for your analysis, and you can incorporate all this data for your research. And you see global road open. You can download the road networks. So that is fun. Many a times our students do digitize from topo sheets and other sources. These are the main roads, these are the tributary roads and other things. But you do not need to download all the data. You can download it even from OpenStreetMap. You can download the OpenStreetMap. And the beautiful thing of OpenStreetMap, you can zoom to a particular region or smaller area, large scale area. So you can download even the land use, land cover, and other every detail, buildings, roads, road names, including annotations. You can even ferry routes. You see, you can download it from OpenStreetMap for your research, for your activities. So open aerial maps, open land maps, whatnot. Lot of this is not exhaustive list, of course. There are more of this kind of data available free in the internet. Anyone can just download, and just only the condition is that you need to acknowledge the use of this data. This is the front page of our Bhuvan, that is the most utilized by our Indian researchers. They give the thematic maps or 3D. You can see even the 3D data, and you can download the data from this Bhuvan portal, beautiful portal. And this is the data, this data source. I prefer this data set very much, because Bhuvan has some limitations. You cannot download 20 scenes per day, but this has got no limitation, and it gives data unlimited. So starting from aerial imageries, you can download up to our ISRO. This is also giving our ISRO data, even list 3 data, resource 2 data is also available from this USGS website. And of course, the Landsat data is also available, Landsat data, every kind of Landsat data, even some thematic maps, ready thematic maps, global forest, agriculture, precipitation, elevation, ready maps we can download for our analysis from this USGS website. Beautiful raster data set from free. This is free and open. And many a times we need to have some vector data as well. For example, administrative boundaries of India, or even it up to Tehsil level, block, not block, up more than block level. So global level data. This is global level data. All country of this world, have their data. So if you select India, we can download these administrative boundaries in vector format. And if we download this inland data, this is also vector. You see, we can measure the length, or we can measure the area of that particular ponds, tanks, lakes, reservoirs, roads, railways, elevation, land cover, population, climate, and even the gadgetier. So that is a beautiful data set, Diva GIS. So they are also giving the software. They have their own softwares. And another services, given by our DST, Department of Science and Technology, Government of India, through their iGate portal. This is a beautiful but less explored portal, and it gives tutorials, very well documented tutorials on understanding GIS, understanding remote sensing, lot of databases which is given, how to do spatial analysis, what are the recent trends, that means web GIS, web GIS or mobile GIS, how can you customize your GIS. So all these things, all this data, all these tutorials, it is available through this iGate portal. And the resources are various websites, including job portals, various data sets, lot of books, lot of programs, training programs, and resource person. You can see these are the location of the resource person. Unfortunately, they could find my name here, so anybody can just email. You can click over here. If their detail it is available, you can click to any of the resource persons for your inquiry, and the resource person will answer your queries or doubt. So that is a beautiful website, and data support for learning GIS by the Government of India, DST portal. And this is one of the latest, services by NASA, Giovanni. So that is really excellent for environmental studies. You can see this open source that can give 266 sources of aerosols, atmospheric chemistry, atmospheric dynamics from 803 sources, cryosphere from 17 sources, hydrology from 481 sources. These are the basic disciplines and if we take the measurements, you know, what is the date, I mean, how the measurements are done. You can see aerosols, AOD, air pressure, air temperature, CH4, CO, CO2, whatnot. Every atmospheric chemistry, atmospheric particles. This is not the exhaustive list. They are long. This is a really long list. Long list, you know, for these measurements, and there are different platforms, different spatial and temporal resolutions in different wavelengths, and you can get the map directly. The map, you do not require even to produce the map. The map, you can ask for the map, it will give you the map. If you ask for the XY, I mean Excel data, it will give you the Excel data with location. You can have your own choice of data range. For example, what was the pollution level or CO level, carbon monoxide or carbon dioxide level for yesterday's, you know, few days back, I mean 2 days back, Diwali. So you can put this Diwali date and you can ask the latitude, longitude, or even you can browse from map for Kolkata or for Delhi, for entire India or for entire world. You can get the any kind of, say, data and their map, or there are many other services through this plot. You can plot exactly that. There are XY plot also. It can give you the analysis portion also. So that is the very few open sources geospatial data. And now my final part is the visualization method. Okay, what I understand, visualization is the process to communicate information clearly, efficiently with the audience. You know, that is the display of the data, how you display your data for the audience, for the reader, and that should be very easy. So the reader should not have much, you know, training to understand the data. So that is the visualization aspect, and through GIS we can definitely, already that has been discussed, we can prepare thematic maps with different kinds of thematic maps, taking a particular theme. For example, temperature, global temperature for today's, you know, afternoon at 3 p.m. what is the global temperature, just we can prepare a thematic map. Similarly, static maps, some complex kind of map, 2-3 types of maps, but that has got no, you know, GIS background support. Maybe we can have static map. Of course, that is a trend nowadays. Everything is coming as wave. What Mr. Datta was telling was IoT. So this Internet of Things or web applications, that is the beautiful aspect and coming heavily on us, and that is the future of GIS. And these two, combining this web application and mobile applications, I believe these two are very close, very integrated to each other. So for these mobile applications nowadays, we do not like to open the desktop or laptop for web GIS. We just want to see what is there happening through our mobile, and we want to upload the latest information. So what Dr. Parthu sir was telling about, you know, taking geotagging the photo. So where there is a some bank failure or a bridge collapse or an accident or a road crack, whatever, bridge crack. So you just take a photograph on your mobile, tag it, and send it to the planners or administrator so that they can take the decision on it. So that is the mobile applications, and we love it very much. And of course, the city that we are just seeing, visualizing the campus map, university campus map, that was the 3D map. That was really excellent applications of GIS or visualization method of GIS. And that is beautiful application. That is a very own concept of ESRI, that is map story or story maps, telling story of transformation of particular land through time. So storytelling like thing through map. So, and another biggest applications coming, this open layer geo layers. You know, there are open layers freely available. You can just upload your data to the open layer, so that the data is visible to the world. Data is visible to your peer group. Data is visible to your contacts or whom you want to share that data. Maybe it public, maybe it personal, maybe it global, like thing. So these are some tools or techniques, you know, to visualize your data and just make it, you know, these are the diagrams. Say for example, we can prepare arc diagram, area diagram. These are very common kind of tools, bar charts. We can go for density plots, flow map, flow chart, whatnot. These are the, of course, these are not exhaustive. There are more of this kind, but these are a few of the tools or techniques available for presenting your data on map, so that people can understand your data, your map in better way, without much complexity, without much expertise in analyzing data. So your map should be self, interpreting the data we are giving. And as was talking about the open source, so this is QGIS, Quantum GIS, an open source GIS software, and it has its own, like any other software, it has its own visualization techniques of data through various GIS techniques. But in particular, it has got, the QGIS has got many add-ons, or we can say plugins. So Data Poly is Plotly. Plotly is one of the plugins which helps to plot the data or visualize the GIS data through some specific techniques which is not available in Quantum GIS or GIS software. And we can do a lot of modifications, customization of this of our data using these basic plots like box plot, bar plot, contour, histogram, pie, scatter, ternary. So these are the basic plotting or visualizing methods. And we can download this plugin using there is a plugin, so plugins available. So we can, this is the plugin, we can go to the plugins, lot of plugins is there. And the QGIS is a specific particular plugin, data analysis and visualization. So we can download this latest plugin for visualizing our data. And I think this is the final sheet. This is one of the data regarding COVID. Nowadays we are just all restricted this webinar also due to this COVID, and I thought this would be an example of visualizing the data. You can understand it is the 31st of July, and we are having West Bengal government's provided data of COVID. It is absolute number, I think, yeah, absolute number COVID affected, and the Lorenz curve is showing a huge disparity in distribution. So these two districts, Kolkata and North 24 Parganas, it is holding the maximum number of 90% of the patients of all COVID, and the rest of the districts are having very, and these are the, I think, safest district, this Purulia and this Kuch Bihar. These two districts are the safest so far regarding the COVID. So in that way, we can present the data, we can visualize the data. And yes, with this, I would like to stop here. Thank you so much for your patient hearing. Thank you so much for giving me the opportunity. Thank you.
Dr. Biswas. That was really a wonderful presentation and very helpful for the GIS community. I request all of you to keep your microphones muted and cameras off. Distinguished speaker is Dr. Shreyoshi Shatra Mitra. She is an executive committee member, ISRS Kolkata chapter, and assistant professor, engineering department, Haldia Institute of Technology, Haldia. I would request Dr. Mitra to give a brief presentation on GIS maps, the technology, and Dr. Mitra, please.
Good evening to you all, and very happy GIS Day as well. Myself, Dr. Shreyoshi S. Mitra, and I am an assistant professor working in the Department of Civil Engineering in Haldia Institute of Technology. And thank you so very much for having me here for the presentation on GIS maps, the technology and applications. But before I start with my presentation, I would like to share a few words with you all. That in my presentation, while making it, I have incorporated materials from diverse sources. So if you want to know more about the sources, or if you have any query at all about the sources, you are welcome to contact me directly in my mail ID, which is mentioned right in the title slide. You can find there. It's sreyashi.mitra@gmail.com. You're welcome to contact me anytime. So let's get started with the presentation directly. Now, as I told earlier that my topic of discussion will be GIS maps, the technology and applications. So let's start with the definition of map. What is map? A map is a symbolic representation of selected characteristics of a place, usually drawn on a flat surface. Now, here 3 points can be noted. That is symbolic representation. That means we are using symbols to represent some of the selected features. Why selected? Because on the Earth surface, many features are available, but we cannot just plot all of them all together on a piece of paper simultaneously. So we need to depend on the theme itself to guide us in selection of some features which can be represented on map so that the theme can be properly reflected through the map. And as per the conventional definition as well, it should be drawn on a flat surface. Now, whatever science or technology or art we are using to make the maps, it's called cartography. And geospatial scientists, geographers, geophysicists, whoever are dependent on the maps, they would agree to at least one point that whatever map is being produced, it has a story to tell. Whatever it is, it has a story to tell. So, and a cartographic language is being used to make that story. Now, when we think about the maps itself, images probably come to mind of paper fold road maps or perhaps an atlas we used in school days. But today's GIS maps go far, far beyond that static map of years past. But in this journey, from the paper map, a dam map, to the GIS map, modernized map, this transformation has taken place across the years, and maps have experienced so many changes in this journey. In our old days, there were only paper maps available, that is with a fixed scale, and very limited amount of information were available, single level or multi levels. There were actually man-made maps were those, and it was very laborious to make it, and reproducibility was very much less. But after the advent of computer technology, digital maps were made common, and it's more like hard maps in the soft platform. We could see it in a digital screen in digital form. We could zoom in, zoom out, but the problem was both the integration or extraction was not that much easy. I cannot say it's not possible, but it was not that easy. There were a lot of processings to be done before we could do some GIS on it. And lastly, GIS mapping is the process where we can have our modernized map, where user control is there. We can reproduce it as many as we want, and as many time as we want them to be reproduced with different scales, different information, multi-level informations are there. We can put different queries to produce a new map from the existing information. So we can do so many things in GIS maps. This is a modern type of map present here. Now, what are the application sector of GIS maps? So we can think of different sectors where actually GIS offers its service to, like planning analysis, operation awareness, field mobility, data management, so many of them. So if we are providing them with just a tabular information with different data, that is not at all, useful for them. Rather, if we can provide them with all the data mapped properly, then they can actually visualize it and extract information out of it effectively. And if we club all the sectors wherever GIS can be applied in different forms, these four can be major ones. Like maps in governance, maps in businesses, maps for citizens, and maps for researchers across various disciplines. Maps in governance, what does it do? GIS-based mapping helps the government achieve better governance. They actually enable them to solve problems very quickly and very efficiently. For an example, if you talk about this map, Here, all the buildings, yellow color coded buildings are suppose residential ones, and other rest of the buildings, color coded buildings, are commercial ones. So actually, if the revenue collection team is given with this map, they could actually count the properties in this area, which will provide or which will give residential tax or which will provide commercial tax. So they can actually calculate the exact amount just looking onto the map. And also, if we can geotag it along with the address, every building is tagged properly on this map, then the task will be easier for them, because they could actually know the building with the address and their amount, their floor size. Every information can come up with a very, very useful way to them. And then again, if we are talking about water resource management department of any government, and if they are provided with this kind of 3D enabled visualization system, where they can actually see the layout of the entire area with 3D dimensional portrait, with a virtual reality world and system, and also they are provided with some kind of error map where the malfunctioning tubes or knobs are there. So if they know that where exactly the fault is, they could send the, suppose this is faulty one, so they can actually provide their team to repair it, and this will be done in a minute, in 1 day or 2 days, I mean very quickly. So in this way, GIS maps can be helpful in proper governance. And now what about maps in business? Business personnel also are nowadays extensively using GIS maps. Why? Because customer mapping is something which enables organizations to identify the markets. Suppose here we can take an example of a person who is a clothing shop center, who runs a clothing shop center. And he wants to relocate it, and he wants to just sell child clothing. So what he will do, he will need one GIS map where age-specific population distribution is there, because he wants to know, he needs to know where is the child population is maximum. So he would relocate there, and he could maximize his profit just like that. Maps for citizen also is very important, and here public and private, both the sectors are working hand in hand to produce different types of facilities for the citizen. Suppose a citizen is provided with this map, and suppose he is residing over here and he wants to buy a land somewhere which is near healthcare facility. So he actually, using this symbol, he can actually see where are the healthcare facilities located on this area. So his decision will be much more, definite and very easy if he wants to relocate himself near a healthcare facility. Likewise, in this way, citizens' decision support system has been enhanced by giving GIS support system. Now, what about maps for researchers? Researchers across various disciplines are actually taking help from GIS as well. And it helps them to a larger extent. For an example, suppose a medical scientist has been provided with a COVID concentration map, where he can see actually which are the areas which are extensively COVID affected. So based on that area only, he would try to seek for the reasons which is aggravating the situations, deteriorating the situation, so that he could come up with a proactive plan to minimize the problem. In this way, geophysicists, geographers, climate scientists, meteorologists, all of the scientists are using GIS help or GIS maps help to either carry out the study or show the end products of the research. Now, next comes the visualization part of this. If we are going to the GIS mapping technique, we can actually see that GIS mapping can be done using 3 systems: reference, thematic, and dynamic. If we are talking about only showing the location, then we use reference. If a theme has to be represented in a proper way, then actually we do use a theme like this, any of this, to produce that, to represent the type of data like population or precipitation or vegetation covers. These things can be effectively represented using any kind of thematic type. But the problem is, if I start talking about this, then it won't end our presentation. So I'll be restricting within this only. And dynamic mapping is something which is more user-centric than the content-centric. Unlike a hard copy map that has a features and elements users cannot modify or change, dynamic maps encourage and sometimes require user interaction. Using that, they could actually do so many things interactively and customize the map according to his choice. So this is all about the techniques. Now, as we have GIS maps ready with us, how would we visualize it? Will it be a 2D model or 3D model, or a fourth or fifth dimension to be added into it? Can be added into it. So let's see each one of the cases. If we are really interested in 2D mapping, each and every object is shown on only a flat surface, where we only need X and Y. There is no possibility of giving a third dimension, that is usually Z. Look at this map. Here we can see that every single object is on the flat surface. Now, if we want to make it much more realistic, and if we want to add a third dimension to it, that could be a 3D model where Z dimension is added in terms of elevation itself. Now, let's look into this, where we are using actually triangulated irregular network, or TIN, to represent the 3D model of a relief. But the problem is, it is having a problem that it cannot hold multiple Z information of a single X and Y point. That means a particular point with X and Y, fixed X and Y entity, can have only single Z information that could be represented by TIN. The problem is, if you're talking about a building for a particular X and Y location, we may have multi-floor information with different elevation statistics or data. So that's where TIN cannot hold the GIS model properly. And also another problem is that TIN cannot show something which is completely vertical. So why it is, it needs some other explanation as well, but I'm not going to talk about that much in here because of the time constraint. But I would like to mention that if we want to do something like that, extrusion capability was introduced into GIS, where we can just extrude the building based on its elevation only from the base thing. But the problem again is it was not able to show the GIS. The ancient GIS couldn't able to show all the geometry, exterior geometry in its present platform. So we had to use some third-party software, very high-end drawing software like SketchUp or Revit or 3D Auto or CAD, this kind of software to put the exterior models. But afterwards, some other, software which are very, very high-end one are getting developed, like Rhinoceros coupled with Grasshopper by Robert McNeil and Associates, or City Engine by S3. What they can do is they can actually provide a lot of information in 3D domain, and they can actually hold the GIS data in 3D and also give the users ability to insert some design information onto it. So what about the fourth one, that is the 4D? Now the 4D obviously will refer to the time dimension. Time dependent any data or temporal data, such as data describing changing weather conditions or fire propagation. These is supported by most of the GIS system through the use of animation tools. It cannot be shown just like that, but it will be more like an animation series. But the problem is little or no support is provided for data analysis, and that's why we cannot just predict for the future. We cannot do projections. Growth models like carbon growth, policy impact models, the spread of forest fire, etc., are supported at least in a limited way. I mean, we can use 2D maps and also geoprocessing tools. We can do some kind of animation added to the 2D model itself. What are the uses of this kind of model? We can use it in flood model, fire model, evacuation model, etc. So we can use one animation model to get the idea more clearer. Now let's have a look into an animation model. Suppose this animation model, it is reflecting one tsunami inundation model, and where we can see that how water is getting into the land and land is getting inundated as time passes by. This will be the time frame to look into. Suppose I'm playing this. So we can say as time is getting increased, the water is getting into the land and the land is getting flooded. Right? This is a typical animation that we can think about. Now, as I told, this is a particular animated 4D sample. Suppose our complex minds want to know something more from it. Suppose I'm playing this. The water is getting into the land. Suppose in this timestamp, this much buildings have been underwater. Now, if I'm interested, after this time, how many more buildings have been underwater? I mean, before time 1 and after time 1, if how many buildings were underwater, more buildings were underwater, then what we are doing? We are adding simply an additional time scale to our 4D model. There comes the concept of 5D. The fifth D refers to attributes associated with the space or time defined by the first 4 Ds. This is a relatively very new technology to map and visualize GIS output in a 5D enabled map. This fifth D, as I told, refers to the scale, spatial or temporal scale, which is attached to the 4D model. So this enables us to compare between spatial and temporal elements. But the idea of 5D GIS is just now the beginning to emerge in the minds of GIS professionals. And as a consequence, this phrase is becoming a part of normal GIS conversations, though it's not available in reality. The implication is that today's GIS supports the part of it. Like first 4D is okay, fine, supported, not fully, partially, but 5D we can think of. Our mind can think of, but exactly the thoughts of how to get it done is not that much available right now. We need a lot of things. The thought of developing a fully capable, truly 5D GIS system would face a mountain of impedance. New conceptual models, data structures, analytical procedures, graphical models, these all would need to be developed in a large version, as well as new visualization strategies and tools also for navigation, also to be made available before we can even think of 5D. However, the extent and pace of development that we are experiencing nowadays, we can see that in near future, we can have 5D model as well, 5D GIS mapping as well. GIS is strengthened every single day with the development in a computational and programming world. The world is getting smarter, we are becoming smarter are the cities. More smart cities are envisioned by every single country. So only one thing would be common for all of us. If we want to make ourselves smart, if we want our city to be smarter, then obviously we would have to envision our maps to be smartest enough. So, and GIS could do wonder in yielding those efficient maps. So on this note and on this hope, I would like to end my presentation for today. I hope that through this presentation, some information has been disseminated among the audiences. With that hope only, Ms. Shreshti S. Mitra would like to end this presentation. Happy GIS Day. Wish you a very, very happy GIS Day indeed. And good night. Thank you.
Thank you, Dr. Mitro, for such an interesting and informative content. I would like to inform all the participants here that a link will be sent to your email address tomorrow to view. You are requested to submit the review by 30th of November 2020. The certificates will be mailed back instantly after the submission of the reviews. Okay. So we are next respected speaker. Our next eminent speaker is Dr. Shondha Bhaduri, an executive committee member, ISRS Kolkata chapter, and former director of NATMO, Government of India. Dr. Bhaduri will discuss about application of GIS techniques on geomorphological studies. Dr. Bhaduri, please.
Good evening to all. This presentation deals with two disciplines. Both are very vast. One is remote sensing, another is geomorphology, which is a science of study of the landforms of the earth. Geomorphological mapping from satellite and aerial images needs a thorough knowledge of the subject geomorphology, how certain natural and man-made processes lead to landforms. Geomorphological analysis of surface forms of the earth is a direct form of interpretation from space images. Geomorphology as a science developed much later than geology and deals with the genesis of relief forms of the surface of the earth's crust. A thorough understanding of various natural processes leading to landforms is necessary to understand the environment in which we live. Remote sensing is an effective tool because images contain integrated information of all that is around us. These are landforms, the ecology, the resources contained in the areas, and the impact of human action on the natural landscape. Factors responsible for landforms deformation. The Earth's surface forms are primarily due to endogenous processes leading to geological structure, tectonic activity, and volcanism, leading to volcanic landforms. These forms are modified by exogenous processes, which include erosion and depositional activities of water, wind, and ice. Other activities, weathering, mass wasting, or movement of materials by gravitational action, land-ocean interaction resulting in landforms due to waves, currents, tides, and tsunamis. Climate is another important factor, act upon the surface material, which are different in different climatic zones. Time is also an important factor that may preserve or destroy the natural landform because it controls the stage in the sequence of processes leading to forms. These are the landform indigenous process with earthquake, earth movement, and volcanic eruption. The landforms due to exogenous processes, these are the creation of the exogenous processes. Classification of landform, natural processes and anthropogenic causes responsible for various landforms. Those are the processes, the local and the regional, from its tectonic or structural, from to anthropogenic, which is very important nowadays. Geomorphological mapping. This geomorphological map must give information about morphology, that's appearance, morphometry, dimension, and slope values. Morphogen is origin, and morphochronology, the time scale. The analytical geomorphological maps serve as a basis for applied geomorphological mapping. That includes morphogenesis, morphostructure, morphometry, and morphochronology. Morphostructure is underlying bedrock and structure which have a profound influence on the landform. Then morphochronology, different ages of landforms. The analytical geomorphological maps, these maps, applied geomorphological maps, can be derived from analytical and synthetic maps. Synthetic geomorphological maps, it contains in addition to 4 levels of certain mapping units, also contain additional environmental information subsequently on the basis of number of the site observations. These observations include soil, hydrology, vegetation, land use, land cover, and topography. Geomorphological mapping, the pragmatic or applied geomorphological maps relates to natural hazards. Hazard assessment and development from mitigation program are increasingly becoming useful, as hazard zoning, which has a direct bearing on geomorphology, is possible in all cases. Maps on flood, mountain hazards, drought hazards, earthquake, volcanic zoning, cyclone hazard zoning, maps for mineral and hydrocarbon exploration with geomorphic anomalies are some typical examples of pragmatic geomorphological maps. Remote sensing application. The remote sensing is electromagnetic energy interacting with matter recorded by sensor, is seen as an image. The electromagnetic spectrum ranges from meter to nanometer in wavelength. Spectrum has several windows through which reflected or emitted radiation is recorded. The common type of sensor are as follows: aerial camera, multispectral scanner, thermal scanner, active microwave sensor, which is a very much important advantage of recording day and night as well as through clouds. Advantage of using remote sensing in geomorphology. The dynamism which is responsible for changes occurred in the landscape is effectively brought out by repeated coverage of images of the same area at different times. Changes in land use pattern. Multi-temporal capability. Indian satellite at a height of about 800 km revisited every 22 days. But no change occurs in major landforms in this short period. Changes brought about by natural disaster like flood, cyclones, landslides, changes in river courses, erosion of the river banks can automatically detected. The multispectral capability. The advantage in multispectral capability, combination of bands provide better contrast for image interpretation. And the satellite multispectral data have an advantage. Image data is various bands can be subjected to digital enhancement techniques. Then the 4 phases of image interpretations are detection, recognition, and identification. Analysis, classification of observable features in terms of landforms, and genesis. Multi-spatial capability. Sensor improvements, with the help of sensor improvements, 1 meter resolution data are available, other resolution ranging from 2 meter to 1000 meter or more by satellite. This provides opportunity of multi-spatial capability. For regional mapping, low resolution data may be adequate. Landscape ecology of a small area, high resolution data may be appropriate. Microwave remote sensing in geomorphic analysis. Radar, being an active sensor, provides all weather capability, including day and night observations. Radar backscatter is sensitive to different set of properties like surface roughness, slope, and dielectric property of surface material. Radar image for terrain analysis. This shadow effect and the subtle elevation difference, which are not directly perceived in optical remote sensing image, are highlighted in radar image. The interpretation of radar image is based on the form, topographical texture and pattern, topographical position, pseudo 3D presentation of form. Yes. One of the most commonly using application, mapping of flood and cyclone affected areas. The land system are units having a unique character of landforms, soil type, vegetation, and land use, which can be extended to other characters like groundwater condition, slopes, etc. The close linkage between the landforms and other ecological factors are reflected in the aerospace imagery. Aerial photos used to capture ground features. The basis elements are shape, size, tone, texture, slope, etc., related to the scale of aerial photos. The advantage of aerial photos is that they provide stereoscopic view, enabling the interpreter to understand the genesis of landform in addition to amenability to measurement of slope, heights, etc. Interpretation of remotely sensed images from space platforms for geomorphological understanding is rather direct. The synoptic view of a large area in a single view enables understanding of interrelationship of various terrain features. Because of the time limitation, I conclude. Thank you all.
Thank you so much, Dr. Bhaduri. That was really very useful. So now I would like to request Dr. Tuhin Bhadro, an executive committee member, ISRS chapter, and assistant professor, Adamus University, Barashat, to give his presentation on GIS-based hydrological modeling. Dr. Bhadro.
Myself, Dr. Tuhin Bhadro from the Department of Geography, Adamus University, Kolkata. Thankful to the Chairman Sir, Indian Society of Remote Sensing, Kolkata chapter, for giving me the opportunity to deliver a lecture in the GIS Day Celebration program. Today I will present on GIS-based hydrological modeling. So what is hydrology? It is a branch of water resource, refers to the movement, distribution and quality of water on Earth. We know that water is one of the most vulnerable resources on the Earth's surface. Water is under stress due to its limited supply and increasing demand. Uneven distribution of these water sources is one of the major causes of water scarcity throughout the world. Therefore, for sustainable water resource management, proper quantification of the resource is highly essential. The hydrological models helps us in the quantification by replicating complex hydrological processes. It also helps us to predict possible changes in water quantity as well as quality. Hydrological model can be basic model of how rainfall affects the water level in a stream, to a complex and wide-ranging global model of the effects of climate change on available drinking water. GIS-based hydrological models are most widely used hydrological models which are based on our understanding of the physics of the hydrological processes which control the catchment response and use physically based equation to describe these processes. Now we will see the role of GIS in hydrological modeling. We know geographic information system helps to integrate spatial information to support operations, management, analysis and decision making. It is a very helpful tool for understanding different water resource issues like flow estimation, water quality, groundwater contamination, river restoration, flood protection and management. GIS-based hydrological models are extensively used to estimate the water yield from ungauged river basin all over the world. Besides GIS, remote sensing also play a crucial role in GIS-based hydrological modeling. Remotely sensed data provides spatial information like land use, land cover information, which is one of the most important input data of the GIS-based hydrological modeling. Digital elevation models like SITM, ASTER are commonly built using data collected using remote sensing techniques. These DIMs are used in hydrological models for river network extraction or watershed delineation. Finally, these remotely sensed data are
ডক্টর ভদ্র আপনি একটু জোরে বলুন, আমরা শুনতে পাচ্ছি না আপনাকে একদম।
GIS platform.
ডক্টর ভদ্র আপনি একটু জোরে বলুন, আমরা শুনতে পাচ্ছি না, কেউই প্রায় শুনতে পাচ্ছি না।
বিপুবাবু, এটা রেকর্ডেড, এর ভলিউমটা এরকমই আছে। একটু সিস্টেমে সবাই নিজের নিজের সিস্টেমে একটু ভলিউমটা বাড়িয়ে নিন কাইন্ডলি।
না, এটা আমার ম্যাক্সিমাম। ওকে ওকে, চলুন।
এটাই ম্যাক্সিমাম ভলিউম আছে।
Please continue.
protection or watershed delineation. Finally, these remotely sensed data are integrated with other secondary and primary data on a GIS platform to replicate different hydrological processes. So before I start the GIS-based hydrological modeling part, I will quickly show you two important methods which are used in most of the GIS-based hydrological models to simulate hydrological processes. First is water balance method, which is related to the hydrological cycle, which is a fundamental element of hydrology. And you can see the hydrological cycle here. It describes the continuous movement of water on, above or below the surface of the earth. The different components of the hydrological cycles are precipitation, interception, depression, storage, infiltration, surface and subsurface runoff, soil moisture content, groundwater flow, evapotranspiration, etc. And the water balance equation maintain a balance among these components. So this is a water balance equation. And the second method is NRCS curve number method, that is natural resource conservation curve number method, which is used in GIS-based hydrological models to estimate the runoff information from rainfall data. In this method, runoff estimation, the effects of surface condition of a watershed are evaluated by means of land use land cover characteristics of the region. In this method, the potential maximum retention is an important parameter to estimate the direct runoff, and it depends on the land use, land cover, and soil characteristics of the region. According to this method, the soil of a region can be broadly classified in 4 categories. So these are soil group A, soil group B, C, and D, which are classified mainly based on the rate of infiltration and water transmission of the soil. The potential maximum retention also depends on the antecedent soil moisture condition just before the beginning of the rainfall event. So we are getting information about the hydrological soil characteristics, land use land cover characteristics, and AMC, and the role of GIS is to integrate this information to estimate the curve number, which is essential to estimate the potential maximum retention. And if we have the precipitation data and if we know the value of potential maximum retention, we can estimate the runoff information using this formula. Now I will show you a specific GIS-based hydrological model SWOT, and we will see how it works. SWOT is a physically based spatially distributed hydrological model. The SWOT model requires elevation information, that is DEM, land use land cover information, soil information, and weather information of the basin to generate synthetic flow data. The model delineates river network and subbasin from digital elevation model, and subbasins are further into hydrological response units based on the slope, land use, and soil characteristics. And this is a study area map, the Ajoy River Basin, and the river Ajoy is one of the major easterly flowing tributaries of the river Bhagirathi Hooghly in West Bengal. The river originates from a small hill at Munger in Bihar and flows through Jharkhand and enters into West Bengal at Shimrali near Chittaranjan. And this river basin map or this study area was used for calibration of this SWOT model. So now we will see the detailed methodology of the hydrological modeling, and these are the input information. 1, SITM digital elevation model of 30-meter resolution. 2, land use land cover information. We are generating from Landsat TM image of 1995, FAO soil map, and 4, IMD or Aphrodite rainfall and temperature data from 1970 to 2016. So in the first step, the model generates the flow detection and flow accumulation raster from the digital elevation model, and then delineates river network and subbasin using this flow detection and flow accumulation raster. In the second step, the model generates hydrological response units, and from the unique combination of soil information, land use information, and slope information based on some threshold values. The third step is to feed rainfall and temperature into the model. Finally, the model has been run from 1970 to 2016, and the initial 5 years has been set as a model warm-up period. The model generates flow information of the river based on the input data, and the SOFI2 algorithm of the SWOT model has been used for model calibration, validation, and accuracy assessment. The model performance has been evaluated using 6 statistical parameters and found to be satisfactory. Now we will see the model input information in detail. So this is the SITM 30-meter digital elevation model, which was downloaded from the USGS website and hydrologically corrected using the ArcHydro tool. The SWOT model utilized the digital elevation model to prepare flow direction and flow accumulation map of the region. The river network, river basin, and sub-basin of the Ojai were generated from this map using SWOT model. And this is how the model generates flow direction and flow accumulation raster from the dam. And flow direction determines which direction water will flow in a given cell. The slope is the ultimate factor in how the water flows in the model. And when running the flow accumulation algorithm, the resulting values range from 1, 2, 4, 8, 16, 32, 64, and 128. So you can see in this box that 1 represents easterly direction, whereas the 4 represents south direction, 16 represent western direction, 64 represent northern direction. And the flow accumulation raster, you can see here the result of flow accumulation is a raster of accumulated flow to each cell as determined by accumulating the weight for all cells that flow into each downslope cell. Cells with a high flow accumulation are areas of concentrated flow and may be used to identify stream channels. So here the cell with a value of 20 represents the cell is getting water from adjoining 20 cells. And this is the flow direction map of the basin. This is flow accumulation map, and here 100 is a threshold value. And next, this is the river network map of the basin, and it has been generated from the flow accumulation raster. And next is the stream order map, though it is not a part of this runoff analysis, but this map has been prepared to understand the hydrological or morphological characteristics of the river basin. And you can see here the shape of the river basin, which has an effect of runoff volume. As the basin is long and narrow, the tributaries are relatively short and joins with the main river intervals along the length. Heavy rainfall over the basin, the runoff peaks of the lower tributaries will leave the catchment before the peaks of the upstream tributaries move far down the mainstream. Thus, the basin less subjected to high runoff peaks. Next, this is the major sub-basin of river Ojai, and the image shows the sub-basin of the 7 tributaries of the river Ojai, namely Dhadwa, Patro, Jamti, Hinglo, Tamoni, Kanur, and Gangatikuri, along with its own basin. The total area of the Ojai river basin, including these tributaries, are 6,627 kilometers. And the SITM dam was also used to generate to the slope map of the Ojai river basin. So this is the slope map, and the slope map shows that the basin is quite flat, and more than 96% area is lying below the 10% slope. The high slope value of 63 degree has been observed in the upper basin, which is also a part of Chotanagpur plateau region. The upper part of the Ojai river basin is comparatively steeper than the lower part, and thereby has a potential to generate runoff faster, and the lower part is flat enough to increase the rate of infiltration, hence restrict the runoff generation. And this is the land use land cover map, which is prepared from the Landsat TM image of 1995. A supervised classification was done using maximum likelihood method on the Landsat image to prepare this land use land cover map, and the map was classified into 6 categories or 6 classes. These are water, soil, barren land, cropland, fallow land, and settlement as per the SWOT model guideline, and accuracy assessment was carried out to assess the precision of the classification. The upper part of the basin is mainly covered by the fallow land and barren land, and thereby has a potential to generate large volume of surface runoff, whereas the lower part of the basin is dominated by cropland and forest, which reduce the runoff volume and increase the rate of infiltration. And this is the zoomed portion of this land cover map, and you can see the land use classes more clearly here. Next, this is the soil map generated from the FAO soil map, and you can see that the sandy clay loam, sandy loam and clay loam are found to be four major textural soil classes in the basin. Sandy clay loam is a major soil type which covers almost 60% of the basin area. And hydrologically, we are getting two soil groups here, soil group C and D. The C soil group covers almost 78% of the basin area, whereas D soil group covers 22% of the basin area. And this is daily precipitation and temperature data during the study period of 1970 to 2016. These were generated from Aphrodite and IMD gridded rainfall and temperature data, and these figures shows the average temperature and precipitation conditions of the upper and lower Ojoy River basin. And this is a schematic representation of hydrological model, and you can see here that the SWOT model utilizes this input information to generate HRU, and it uses water balance equation and NRSC CN or previously ACS-CN method to generate the runoff information from the rainfall data. So this is the basin scale water balance, and we are getting this as an output of this SWOT model, and you can see here that the model has estimated the carb number at 74. Next, this is the validation part of the model, and we cannot use any model output directly without validation. Here, the SUFI2 algorithm of SWOT model has been used for model calibration and validation and accuracy assessment. The Nash-Sutcliffe efficiency, percentage bias, and RMSE observation standard deviation ratio and coefficient of determination were calculated using this SUFI2 algorithm to compare the simulated and measured flow and to assess the model accuracy. And here, these are the calibration period and validation period, which was fixed based on the available flow data, and the performance of the model for monthly time step can be classified into four categories. You can see here these are very good, satisfactory, and unsatisfactory based on these NAC, P bias, RSR values, and the high values of R square and NAC and low values of P bias and RSR indicates a high correlation between the observed and simulated data. Therefore, model performance was quite satisfactory. So this is the final output and the hydrograph of the river Ojoy and its tributaries, and you can see here that the average flow of the river Ojoy at Katwa ranges from 8 to 600 cubic. In a flood year, the peak flow of the river may increase up to 1250 cubic, whereas in a drought year, the peak flow of the river may diminish below 250 cubic, and tributary wise shows that the river Patra has a major contribution in the flow of the river Ojoy, followed by the river Hinglo, Kanur, Jamti, whereas the contribution of the river Ganga, Tikori, Dhadwa, and Chamoni are comparatively less. So finally, you can say that the SWOT model was successfully calibrated and validated to assess the flow data of the river Ojoy. The study proves that the GIS-based hydrological models are efficient enough for water resource assessment in any ungauged river basin. GIS-based hydrological models can provide a spatial element that other hydrological model lacks. Therefore, GIS could be utilized as a suitable tool for solving water resource-related problem from the local.
Our next speaker, retired Professor Dr. Mamta Desai, was the head of the Department of Ecology, Physical and Human Resources, Netaji Institute for Government of West Bengal. She is life member and an executive member of the ISRS Kolkata chapter. I invite Dr. Desai to deliver a lecture of geospatial technology in road status analysis. Dr. Desai, please.
To global scale. So that's all for today. Thank you very much.
Thank you so Much, Dr. Bhadro. That was really a nice presentation on hydrological modeling. And now once again, I invite Dr. Desai to deliver her lecture.
Thank you and good evening to all of you. First of all, I am really grateful to ISRS Kolkata chapter for inviting me and giving me this opportunity to say something regarding my long experience in this field. Today, what I am going to present is based on a premier project venture from the point of view of road status analysis and mapping using GIS and remote sensing technology. It is to some extent based on engineering, geology, and geomorphology. During 2006, National Highway Authority of India approached to our institute to do this job. Prior to this, we had done the same job on all the PWD roads in Darjeeling Hill areas. In this project, I was appointed as project director, and we had a multidisciplinary team including geologists, civil engineers, transportation engineers, soil scientists, me as geomorphologist, and some field assistant and project assistant. Thereafter, again, we had updated the database during 2015 along with the Canadian team deployed by the NH Authority, Government of India. Now I am coming to my presentation. First of all, I would like to say that when I did this job in government level, only MapInfo software were using, and we were asked to do the job on that only. As you know, the region Darjeeling Hill area is consist of 4 subdivisions: Darjeeling, Karsiang, Mirik, and Kalimpong. Now Kalimpong is a separate district. This work is concentrated only within Karsiang and Darjeeling subdivision as NH 55 running through these 2 subdivisions only. I had started work in this region in Darjeeling Hill area in 1998, so I already had ample knowledge regarding this road. Darjeeling Hill area, as you know, for the development of any region along with Darjeeling Hill area, tourism, industry, or anything else, the first priority is the development of certain infrastructure. Among them, road network is most important. As you know, Darjeeling Hill area occupies the lowest latitude of the entire Himalayan chain and has the highest permanent snow cover line. It lies in the direct path of the monsoon winds, for which weathering is very high. It occupies the major transverse structure of the Himalayan and thus exposes all the existing geological belts. Having such geo-ecological background, NH 55 was built during 1888 and had been stable as long as it was covered with dense forest. The main causative factors behind the landslide hazards which were detected by us were large-scale deforestation, lack of proper and controlled drainage management system, Jura blocking due to non-disposable garbage dumping, lack of proper building rules, non-existence of any way bridge. The above-mentioned factors have made this geologically unstable region to a vulnerable one. Considering all these, special databases were developed from the Survey of India topography, satellite images, LIS 3-4 and PAN mass data. These were only available at that time, along with extensive fieldwork using GPS. While working on NH55, it is very important to record data regarding Darjeeling Himalayan Railway, which extends from NGP to Darjeeling, following town, having a total length of 88.48 km. It follows NH55 crossing at 150 points without any gate. Average gradient of the rail line is 1:18, which prevails at track section. A schematic diagram was prepared showing the land cover along the road, the thick forest cover, sparsely forest cover, the agricultural land with or without settlement, wasteland, hazard-prone area, and plantation area. This is the schematic diagram. The geological layout or formation along the road. The Shivalik having bluish clays, micaceous sandstones of Miocene age. The Gondwana or Damodar's coal-bearing sandstone shells, Permo-Triassic age. The Darling group of rocks, biotite gneiss, granite, and schist. The more metamorphosed Darjeeling gneiss overlies the Darling group of rocks across a major thrust and contact zone. This is the broad rock competency along NH55. The vulnerable points which were detected by us were near Rongtong at kilometer 63, near Chunabhati at kilometer 56, near Tindharia at kilometer 53, near Shivkola or Paglajora between kilometer 43 to 45, near Giddapahar at kilometer 34, near Sonada at kilometer 15. Now I would like to say something about the vulnerable points. Near Rongtong at kilometer 63 and near Sonada at kilometer 15, the culverts or causeway below the road bench were blocked with garbage, and the culvert span and were shorter than the Jhora width, for which during flash floods or heavy rains, large volume of water either damage culvert or create a new channel. This picture was taken by Dr. Animesh Bhattacharya during 1998 during a flash flood in Paschim Khola. The region between 53 and 55 near Tindharia, Gondwana coal-bearing rock groups, the local people have tendency to collect fragmented coal either by creating large hollows at the crest of the slopes or deliberately made them burn, for which land subsidence occur in this region. The 14-mile slide at kilometer 43 is not very old, and according to my opinion, it is man-made slide. It was observed that catchment funnel of Paglajora was modified to separate multiple flows and allow them to converge at a lower point. Apparently, it seems it had eased the problem. There is another stream on the Talas Cone which meets Paglajora below the neck point. The net effect, the removal of the toe of the debris, which triggered the whole body, and the result was creation of a new landslide hazard-prone area. This is the sketch map showing status of the 14-mile slide at kilometer 43 to 45 and Paglajora from Dow Hill Chitre village. These are the picture of the gradual development of 14-mile slide in and around Paglajora. Another, a huge lake has been formed below the Nick Point, threatening the downward basin catchment area. Another aspect in this regard is very important, that is, during dry season there is very little water in the falls. But if you look into the lower region in the Shivkhola channel, there is plenty of water. It indicates that there is constant flow below the road bench, creating a void below the road bench, and the road is going down again and again, and as a result, the road has become a naturally sinking zone. The typical biotic gneiss rock and the geological contact area between Darling and Darjeeling in between Mahanadi and Gidda Pahad. In Gidda Pahad area, typical Sakung features are found, which proves that paraglacial area, that it is a paraglacial area. The paraglacial is a term used to denote features and phenomena that are immediately outside of the domain of glacier. The Sakung features is one of them. Such type of features are found in the Rocky Mountain and Alpine Belt. This is typical Sakung features and sagging slope in Gidda Pahad rockfall area in the left, and in the sketch of Rocky Mountain. Now I am coming to the remote sensing application along with database management using GIS. On the left, along NH55, vulnerable areas have been marked, and on the right, same has been attached or superimposed along the road stretch. For this work, we had created database in two separate formats: technical database and road status database. In technical database, it includes geology, geomorphology, soil, vegetation, drainage, vulnerable points, trend of railway tracks, etc., and to a certain extent, some geological features like sinking area, erosion type, etc. The road status, in road status and a database, it is mostly based on engineering geology and geomorphology. We had created database. In this database, we have the GPS location, culvert number, culvert span, condition of the culvert, channel name, channel slope, rock type, land use, status of the parapet wall, retaining wall, etc. were given. During 2015, I was again invited to work with a Canadian team to find out some alternative routes for avoiding the vulnerable areas by the NH authority and deployed by the government of India. Alternative routes were delineated on the basis of previously created database along with satellite data. We had followed first and second order stream on Survey of India topo sheet and superimposed them on the images. Accordingly, on the basis of the image data, the alternative routes were identified As we know, in Darjeeling area, there are two important roads, Pankhabari Road and NH 55 or Hillcut Road. And we identify other roads, that is Shiliguri Rohini Kashiang Road, that the only drawback of this road is there is a flood prone area in between Jaborhat and Rohini. Otherwise, the road is stable and is a good alternative. Another alternative road is Gayabari Gidda Pahar Road. It is very steep and narrow and not suitable for heavy vehicle. This year, the Gayabari Gidda Pahar bypass has been damaged in this way. Now I am coming to the sustainable approach for the road status management and disaster mitigation in the Darjeeling area, for which we have to forecasting of the situation, then evaluation of the pre-disaster situation, then identification and evaluation of the type of disaster, strategies for prevention measures, formation of the technical groups, preparation of the database of the total scenario for future planning, awareness program, warning system, system management for the prediction of the disaster. And these are the sustainable approaches for the road status management in the hill areas using RS and GIS. I am going to show you some of the features for which only human interference is responsible for the damages on the road. This is Gum Kabjhara at kilometer 7. The channel is diverted for construction of Indian Oil petrol pump. And in case if there is any flash flood or heavy rain, what will happen, that only God knows. This is the non-degradable garbage blocking the culvert along H55. And incomplete Jhora training program near Rongtang, which indicates the lack of coordination between NH55, NH Authority and Darjeeling Himalayan Railway Authority. The vulnerable newly constructed road stretch Shimulbari showing glacial deposition. An overview of the newly constructed Rohini Road constructed on a single spur. The garbage disposal by the municipal authorities within the causeway. And the last one is a naturally sinking zone, but every year the region is leased to a person and the house is constructed and is collapsed. Thank you.
Thank you so much, Dr. Desai, presentation by you. So with that, we have arrived to the end of this technical session. Before we proceed further into the valedictory session, I would like to thank all the respected speakers once for taking out their valuable time and sharing their much informative and factual presentations. I would also like to extend thanks to all the participants for attending the webinar. Remind you, a link will be given to every registered participant in their respective email address. Through the link, you are requested to submit the review by 30th November 2020. The certificates will be mailed back to you once the reviews are submitted. And now, I would like to invite Professor Dr. Pradeep Kumar Shikdar, Vice Chairman, Kolkata Chapter, and Professor IISWBM Kolkata to preside over the valedictory session. Thank you. Sir, please.
Thank you. I think you can all hear me. Can you hear me? Hello?
Yes, sir, you are audible.
Yes, yes.
Okay, thank you so much. Yeah. Honorable Mr. Subroto Haldar, Chairperson, ISRS Kolkata, Dr. Parthasarathi Chakraborty, the Chief Guest of today's event, all the speakers, participants, students, ladies and gentlemen. It is my privilege to have been asked to give the valedictory speech on this occasion of celebration of the GIS Day 2020. Now, what I have decided that my talk would be divided into three parts. The first, I would like to address the students on a primer on GIS. And the second, I'll try to sum up today's proceedings. And finally, I'll offer the vote of thanks. That is how I have planned my today's talk. Coming to this, the first part, that is for the students. GIS was first introduced in the early 1960s by Roger Tomlinson for storing, collating, and analyzing data of land use of Canada. Now, rooted in the science of geography, GIS integrates many types of data. It analyzes spatial location and organizes layers of information into visualization using maps and 3D scenes. Now, GIS integrates 5 key components. First, you need a hardware, you need the software, you need data, you need methods, and finally, the most important part is the people, knowledgeable people, both in GIS and also in the domain area. A GIS application or GIS apps are computer-based tools that allow the user to create interactive queries, store and edit spatial and non-spatial data, analyze information output, and visually share the results of these operations by presenting them as maps. As you have seen in all the presentations, there was a beautiful map that were presented. Now, coming to the data, because data is the heart of a GIS, and there are 3 types of data. One is the spatial data, the other is the attribute data, and third is the metadata. Now, in case of spatial data, you have vector data, that is point, line, polygons. You have raster data, matrices of numbers. And then you have images or pictures such as remote sensing data or scans of maps. Then you have the triangular, irregular networks used to discretize continuous data. And then you have the terrain data sets built from LIDAR and other point clouds. Then the attribute data are non-spatial characteristics that are connected by table to points, lines, and polygons. Then you have the metadata, which are absolutely necessary if you are going to use data or if someone is going to use your data later on. It contains information about scale, accuracy, projection, datum, data source, manipulations, and how to acquire data. The scale and accuracy is very, very important, along with the projection and data. Okay, only then other users can use your database. Now, there are many benefits of GIS technology. That's improved. The first one is improved decision by government officials. You can see the road, the last presentation by Professor Desai. And then you have instantaneous collaboration through clouds. You have layer complex data to drive improved decision making, improve transparency for citizen engagement, and identify at-risk or underserved population within a community, improved allocation of resources and planning, then management of natural resources, and improved communication during a crisis, cost savings by improved decision making, planning for demographic changes to community. So you can see there are plenty of benefits from GIS technology, and so we are using this GIS technology extensively. But there are also certain disadvantages of GIS technology which needs to be kept in mind when the students are going to use this technology. That first is the geographic error is increased as you get into the larger scale, as the Earth is assumed to be round, but actually it is not round, so therefore you tend to increase the error. It requires enormous amount of data inputs to be practical for some tasks. Its technical nature may portray results as being more reliable than they actually are, and the errors and assumptions can be hidden. And finally, GIS results are accurate if the input data is correct. So I think, Dr. Chakraborty said that if you, put in garbage, you're going to, get more garbage out of it. So therefore, the accuracy end of the data is very, very important. So GIS expert has to be always aware of the fact that all data are not always correct. So you have to keep that in mind. Because in groundwater modeling and hydrogeological work, I have seen so many GIS maps which are erroneous. The scales are erroneous, starting with the scales. And then, you have produced a map, say, for example, a water table contour map. And I have seen water table contour maps flowing, the contour lines flowing across a river or even going into the ocean. So therefore, the domain knowledge is so very important. It's not just preparing map. What are your interpretation from this map? If you have a contour line flowing over the river or flowing over or running over an ocean, what does that mean? It means nothing. It's wrong. Then I have seen in a semi-arid area, I have seen maps where, they have put the water level contour map and then they have put the topography, the DEM. And then in a semi-arid hard rock area, I have seen that the water table is above the contour. And if you go to the field, nowhere you're going to find these artesian conditions. So these are all erroneous maps. Okay, and then another map I've seen, another map, you're using a depth to water table map and then you're superimposing the flow direction. And that's completely erroneous. And it shows that, you might have a knowledge on GIS, but you do not have the, the domain knowledge. So it's very, very important, when you're using a GIS, you integrate the, the knowledge that you have acquired on GIS technology and also the domain that you are working on to get the right interpretation so that it is useful to the decision makers, to the citizens, to anybody, even to the politicians, nowadays, because politicians also rely on such types of map, what development are taking place in their area, which could help them in the next election. So therefore, it's very, very important that we integrate these two. Now, having said this, now let me move over to, the day's proceeding. Today the chairperson, Engineer Haldar introduced to us the, the meaning of GIS Day and GIS movement, beautifully. Our chief guest, Dr. Parthasarathy Chakraborty, has succinctly introduced the webinar on GIS by a presentation on GIS, science and technology for developmental planning. The first technical lecture was given by Mr. Shantanu Dotto. He's the Group Manager, Technology Solution, Esri India Technology Private Limited. He highlighted the revolution happening in geographic science and technologies which have transformed every aspect of the world economy and government, benefiting the nation. He also discussed about the convergence of GIS with other emergence tools such as artificial intelligence, machine learning, deep learning, and IoT, which has immensely helped in understanding forestry, agriculture, transport, disaster, health, etc. Thank you very much for your erudite talk, Mr. Datto. The next talk was given by Ms. Debaruti Das. She is a state aided college teacher of PND College in Kolkata and also the Joint Secretary of ISRS Kolkata. She gave an overview of how GIS works. She stated that GIS represents the real world in layers of different themes of a given area, helping in better comparative analysis of the areas over time and space in various disciplines. Thank you, Debaruti, for your talk. Dr. Vasudev Bhatto, Coordinator CAD Center, Jadavpur University, and Executive Committee member of ISRSK, discussed the techniques of GIS data capturing and integration of RS and GIS. He emphasized on the fact that integration of RS and GIS technologies can create a synergy in which the GIS improves the ability to extract information from remotely sensed data, and remote sensing in turn keeps the GIS up to date with actual Earth surface information. Thank you, Dr. Bhatto, for your erudite talk. The fourth talk was delivered by Professor Biplav Biswas. He's a professor of geography department of Bardhaman University and also an executive committee member of ISRS Kolkata. Professor Biswas highlighted the various applications of GIS, the availability of free and open source data and software for GIS analysis. He critically discussed the aspects of visualization for GIS data interpretation, such as preparation of thematic maps, static maps, web applications, mobile applications, 3D maps, and other layers. He also mentioned the different plugins for better methods of GIS visualization. Thank you, Professor Bhatta, for your extensive presentation, which was really erudite one. The fifth talk was delivered by Dr. Shreyashi Satra Mitra. She's an assistant professor of civil engineering department of Haldia Institute of Technology. She presented a brief overview about maps, transformation, application, and visualization in GIS environment. Thank you, Dr. Mitra, for a wonderful presentation. The next lecture was delivered by Dr. Shondha Bhaduri. She's a former director of NATMO and member executive council IRR's Kolkata. Dr. Bhaduri discussed on the application of RS and GIS in geomorphological study. She emphasized that there is no substitute for fieldwork in mapping and monitoring of landscape. Thank you, madam, for your lecture. The next lecture was delivered by Dr. Tuhin Bhotro, assistant professor at Adamas University. Dr. Bhotro gave an illuminating talk on the use of GIS in addressing different water resources issues, such as flow estimation, water quality, groundwater movement, groundwater contamination, river restoration, and flood prediction on local, regional, and even global scale. As an example of hydrological model, he presented a case study of flow estimation of River Ajoy using GIS-based hydrological model SWOT. Thank you, Dr. Bhadro, for your erudite presentation. The last presentation was delivered by Professor Mamata Desai, former professor at Netaji Institute of Asian Studies and Executive Committee member of ISRS Kolkata. She gave a presentation on the application of geospatial technology using RS and GIS in road study analysis for development of tourism and industry in hilly areas of Darjeeling subdivision. The study also focused on finding out alternative routes to avoid vulnerable areas. Thank you, madam, for your wonderful deliberation. Now, let me come to the third phase of my deliberation. I would like, that's the, the vote of thanks. I'd like to thank the chief guest and all the speakers for their wonderful presentation and sharing with us their findings and opinions today. I would like to take this opportunity to extend my heartfelt thanks to Professor Basudev Bhatto, Coordinator, CAT Center, Jadavpur University, for jointly organizing this event with ISRS Kolkata chapter and for the enormous cooperation in the organization of this event. I would also like to thank Ms. Dipanmita Mukherjee, faculty, CAD JU, for anchoring the event nicely and smoothly. I'd like to thank all the participants for being with us this evening. I hope all of you have some useful takeaways from this seminar. I would like to thank Dr. Hitendra Padalia, Secretary ISRS Headquarters at Dehradun, for his best wishes for this event. Well, Mr. Chairman, ladies and gentlemen, an event like this cannot happen overnight. The wheel started rolling weeks ago. It requires planning and a bird's eye view for details. We have been fortunate enough to be backed by a team of very motivated and dedicated colleagues of ISRS Kolkata and also the CAT Center of Jadavpur University, who involved themselves to take on the completion of tasks beyond their comfort zone. I think that's the end of my vote of thanks. If I have not thanked anybody I've left out, it's not deliberate, and so therefore I would like to state finally that all of you continue to have a wonderful evening with your family. Thank you very much.